Welcome everybody. Welcome to the chemistry class for today. Welcome everybody to the chemistry class for today. Welcome. You're all welcome to the chemistry class. Please get your writing materials ready. We're about starting. Get your writing materials ready. Get your writing materials ready. We are going deep into chemistry today. Welcome. You're all welcome to the chemistry class. Please get your writing materials ready. We're about starting. Get your writing materials ready. We are going deep into chemistry today. Lord of Jesus. Welcome. As you're coming in, please drop a comment. Let's know you're active. As you're coming in, say active. Welcome everybody. Welcome. As you're coming in, drop a comment. Say active. Let's start. Welcome. As you're coming in, say active. Yes. We have 15 people live now. We have 15 students live now. Welcome. Let's pieces chemistry today. Let's demystify chemistry today. Yes, welcome everybody. You're all welcome. You're all welcome. Let us deal with chemistry today. Welcome, active, active. Get rid of all distractions. Get rid of all distractions. Get rid of all distractions. Welcome. Yes, we are 18 now. We are 18. Where are the rest? Where are the rest? We are 18 now. Welcome, 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 welcome. Where are the rest? 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 Welcome, 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 welcome. Welcome, welcome. We'll start in the next 2 minutes. We'll start in the next 2 minutes. Let's give more time for a few people to join us. Welcome, welcome everybody. Welcome everybody. So I want you to drop what's the first topic in Jamb syllabus for chemistry? Drop it in the comment section. What's the first topic in the Jamb syllabus for chemistry? Drop in the comment section. What's the first topic in the Jamb syllabus for chemistry? What's the first topic in the Jamb syllabus for chemistry? Drop in the comment section. Drop in the comment section. Let me see. What's the first topic in the Jamb syllabus for chemistry? What's the first topic in the Jamb syllabus for chemistry? Someone says separation techniques. Okay, Binta says separation techniques. Drop your comment. Let me see. What's the first topic in the Jamb syllabus for chemistry? What's the first topic in the Jamb syllabus for chemistry? What's the first topic in the Jamb syllabus for chemistry? Drop in the comment section. Let me see. What's the first topic in the Jamb syllabus for chemistry? Separation technique, separation technique. Everybody saying separation technique. What's the first topic in the Jamb syllabus for chemistry? Let me see, let me see, let me see. Everybody saying separation techniques. Good, 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 good. Good, 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 good. If you've written Jamb last year, what did you score in chemistry last year? What did you score in chemistry last year? What did you score in chemistry last year? Let me see. Say I scored 56. I scored 50. Okay, I'm seeing your scores. Well done, class. What did you score in chemistry last year? 43. 43. I'm seeing 43. I'm seeing 43. What did you score in chemistry last year? Let me see. Drop, drop, drop. We're going to make this year better. We're going to make this year own better. What did you score in chemistry last year? 40, 43. I'm saying 43. Interesting, interesting, interesting. Okay. So class, let us get started. You're all welcome. You're all welcome. Before we start, to be sure that you're ready, everybody type ready. If you're watching me now, type ready, type ready. Type ready and we'll get started. Type ready and we'll get started. We're looking at chemistry today. If you're in this class, you're lucky because this will be our first serious class on chemistry. This will be our first serious live class on chemistry. So you are very lucky you are starting with us. And if you follow this class, you will not score anything less than 90% in your Jamb chemistry. This is the Jamb Master Live Teaching. You are going to be breaking down and demystifying chemistry from the foundation, from the syllabus. All key topics in chemistry will be dealt with to ensure that you smash your Jamb this year. Type ready in the comment section and we'll get started. Type ready, type ready, type ready. If you state it this time, well done. It shows that you want to pass. It shows that you want to pass. Type ready and let me break down chemistry for you. From the foundation, if you've ever had issues with chemistry, today is the end. If you've ever had issues with chemistry, today is the end. If you ever had issues with chemistry, today is the end. Today is the end. Today is the end. Today is the end. Type ready and we'll get started. Type ready and we'll get started. Type ready, we'll get started. Excellent. I love this set. This is good. Everybody's typing ready. Make sure you are typing ready. Make sure you are typing ready. You must not write Jamb next year. Type ready if you don't want to write Jamb next year. Your mates are typing ready. Join them. After this year, you will not type ready again. After this year, you will not type ready again. Type ready. Type ready. If you have your friend that is writing Jamb this year, send that link to them. Let them come and learn. I made today's class open for everybody. Let them come and learn. Let them come and learn. You must not write. I must not see you next year. I must not see you in my Jamb class next year. Type ready. This year must be your last Jamb. This year must be your last Jamb. Type ready. I must not see you in my Jamb class next year. Don't come for my Jamb class next year. This is your last Jamb. Type ready. Type ready. Type ready. Let's start. Type ready. Type ready. Type ready. Type ready. Type ready. Welcome everybody. Welcome. I like the energy. I like the energy. I love 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 the energy. Okay. So class, we're going to start with the first thing you should learn in chemistry. We're going to be looking at matter. Matter. After matter, we'll then be looking at pure and impure substances. After matter, we'll then be looking at what we call pure and impure substances. Pure and impure substances. Pure and impure substances. Now write down matter. Class, we all know from our secondary school that matter is anything that has weight and occupies space. Matter is anything that has weight and occupies space. Matter is anything that has weight and occupies space. I hope you can see the board clearly. Can you hear me clearly and can you see the board clearly? Can you hear me clearly and can you see the board clearly? Say I can hear you sir and I can see the board. Say I can hear you sir and I can see the board. Say I can hear you sir and I can see your writing on the board. Let me know in the comment section so I will not be teaching myself. Let me know in the comment section. If you can hear me, say sir, I can hear you sir and I can see the board clearly. I can hear you sir and I can see the board clearly. I can hear you sir and I can see the board clearly. I can hear you sir and I can see the board clearly. Excellent. I like everybody that is typing. Thank you. You are giving me feedback. Thank you. Thank you. So I will know what I'm doing. Once you're not hearing, let me know. Once you can't hear me anymore, let me know. Thank you. Everybody that is typing, well done. Well, everybody typing, well done. Well done. I can hear you, sir, and I can see the board clearly. I can hear you, sir, and I can see the board clearly. I can hear you, sir, and I can see the board clearly. Excellent. This is good. This set is ready for me. This set is ready for me. This set is ready for me. I can hear you, sir. I can see the board clearly. Matter is anything that has weight and occupies space. Matter is anything that has weight and occupies space. Now, very, very simple definition. But the next thing we need to look at is properties of matter. So if matter is anything that has weight and occupies space, what then are the properties of matter? If we say matter is anything that has weight and occupies space, what are the properties of matter? Because when we say properties, we mean features or characteristics of matter. How does matter behave? What are the things we see in a substance and say this is matter? Class, under the properties of matter, we have two properties we are going to be looking at. We'll be looking at the physical properties of matter and the chemical properties of matter. If you are watching this video and you had a poor foundation in chemistry, your teacher in secondary school did not teach you chemistry well. I'm going to rearrange your foundation in chemistry today. Physical and chemical properties. So properties of matter, we have physical properties and chemical. Make sure you are writing. Physical properties and chemical properties. Let us start with physical properties. Let us start with physical properties. Let us start with physical properties. You can see how clear the board is. This is live class, which I promised you, live. We are not telling you what we will not do. This is live. This is a live class. See how clear the board is. This is my board, the Jamb Master board. Yes. Class, physical properties. Write them. Make sure you are writing. Clear all distractions. Get rid of all distractions. These are properties associated with physical change. Physical properties are properties associated with physical change. Physical properties are properties associated with what? Physical change. Physical properties are properties associated with physical change. Please take note. In chemistry, you know we have physical change and chemical changes. What is a physical change, class? A physical change is a change that does not produce a new substance. In a physical change, the change does not give rise to a new substance. Also, another feature of a physical change is that what? The change is reversible. A physical change is reversible. Yes, a physical change is reversible. So, we say what physical properties of matter are those properties that are associated with physical change. Make sure you are writing. Get a note for chemistry for the Jamb Master class. Get a note. I'm teaching you a lot of things. Now, what are examples of these changes? Example of physical changes we have boiling. Example of physical changes we have boiling, we have melting, we have freezing. These are some key examples of physical change. Boiling, melting, freezing. Color. Color is a physical change as well. When something changes color, color is a physical change. Color is a physical change. Color. Color is a physical change. Taste. All these are examples under physical properties of matter. Taste is a physical property, physical change. Hardness. Hardness. Malleability. 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 Example of physical properties. Physical what? Properties. Now it's time to go to chemical properties. It is time to go to chemical properties. It is time to go to chemical properties. Please take note, our chemistry class holds on Sundays. Yes. Chemistry holds on Sundays. Monday is for English. Monday is for English. Tuesday is for physics. Marathon physics. Tuesday is for physics. Wednesday is for biology. Wednesday is for biology. Thursday is mathematics. Thursday is mathematics. Friday will just be mock exam day. Friday is mock exam day. Friday is mock exam. Mock exam. Friday I set a mock exam for you on Friday. Mock exam. Mock test on Friday. So Sunday is chemistry. So we start the week. Sunday starts the week. So we start the week hot with chemistry. Hot with what? Chemistry. Monday we enter English. Monday, tomorrow is Monday, right? We're having English tomorrow. Tuesday we then enter physics. Wednesday we delve into biology and demystify it. Thursday we enter mathematics and pieces it. Friday we set a mock test for you. I will be setting mock tests in your 3 subject combinations. The English teacher will set the one for English. But your 3 science courses, I will set it for you on Friday. Every Friday from now till Jamb, you'll be writing mock exam in the Jamb Master class. You must pass Jamb. I'm not joking with you. You must pass Jamb. You fail, I also fail. If you fail, I fail. So you must pass Jamb. Every Friday, you're writing mock exam in your subject combinations. If you're doing math, physics, chemistry, expect a mock exam every week till your Jamb. Every week till your Jamb, expect a mock exam. If you're doing biology, chemistry, physics, expect a mock exam. Fridays for mock exam. If you like this plan, say I like this plan. Drop in the comment section, sir, I like this plan. If you like the plan, say I like this plan. Our class is getting serious now. Jamb is getting close, so we are getting serious. We are getting serious. Let's go, let's continue. If you like the plan, say I like this plan, I like this plan, I like this plan. Chemical properties, chemical properties. So we say physical properties are properties associated with physical change. Chemical properties, on the other hand, are properties that are associated with chemical changes in which a new substance is formed. Chemical properties are properties associated with what? Chemical changes. Associated with chemical changes. Associated with chemical changes in which a new substance is formed. Associated with chemical changes in which a new substance is formed. Associated with chemical changes in which a new substance is formed. Associated with chemical changes. Yes, everybody say I like this plan. This is good. I like this set. I'm enjoying the vibe of this set. I like the vibe. This is my best set. Everybody saying I like this plan. I like this plan. Well done. Well done, everybody. I will help you pass this year by God's grace. I like this set. This set, the energy is different. This is good. This is good. This is good. We say chemical properties are properties that what? Are associated with chemical changes. Chemical properties are properties associated with chemical changes. Class in which what? A new substance is formed. Chemical properties are properties associated with chemical changes in which a new substance is formed. Now, we gave you an example of physical properties, right? It's only right that we give you an example of chemical properties. Class, from your secondary school, remember that chemical changes are irreversible. You cannot reverse them. And a new substance is formed. For a chemical change, a new substance is formed. A new substance is formed. For a chemical change, a new substance is formed. Unlike physical change in which no new substance is formed. In a physical change, no new substance is formed. For a chemical change, a new substance is formed. And it is irreversible. It is you cannot reverse it back. Let us take down examples of chemical change. Number one, we have rusting of iron. Rusting of iron. Rusting of iron. Rusting of iron, burning of wood. Addition of water to quicklime. Addition of water to quicklime. These are all what? Chemical changes. Because no new substance is formed. These are all chemical changes because no new substance is formed. These are all chemical changes because no new substance is formed. These are all chemical changes because no new substance is formed. Class. The next thing we're going to look at now, I want us to look at pure and impure substance. Pure and impure substance. Pure and impure substance. What's the criteria for a substance to be called a pure substance? And what is the criteria for a substance to be called an impure substance? You will learn a lot today. Let's go. Pure and impure substance. Pure and impure substance. Please make sure no battery does not stop you into this class. This is a very long class. So if you have power bank, go and plug your phone to power bank. I'm not joking with you. This is a very long class. I'm not joking with you. Go and plug your phone to power bank. Go and plug your phone to power bank. Make sure your data is not an issue. You must pass this Jamb this year. Pure and impure substance. Pure and impure substance. Write down. Pure and impure substance. Pure and impure substance. Class. When we say a substance is pure, class, for a substance to be termed pure, it means that there's a high level of homogeneity. High level of homogeneity. Homogeneity. High level of homogeneity in the substance. Class, what's homogeneity? In your secondary school, you were taught homogeneous substance and heterogeneous substance. What is an homogeneous substance? An homogeneous substance is a substance that its components are of the same kind. When the components of a substance, the constituents of a substance are of the same kind, that substance is referred to as homogeneous. When the constituents of a substance are of the same kind, that substance is referred to as what? Homogeneous. But when the components of a substance are of different kind, that substance is referred to as heterogeneous. So a pure substance is a substance that has high level of homogeneity. What do you mean by high level of homogeneity? That means the components of that substance are all of the same kind. Then we say that substance is pure. When the all components of that substance are of the same kind, that component is what? Pure. Pure substances, we have elements are pure substances. Elements. Compounds are pure. Because what makes up a compound? Elements, right? A compound is a substance composed of two or more elements chemically combined together. A compound is a substance composed of two or more elements chemically combined together. So you can see that a compound is made up of just elements. Element is made up of just atoms of the same kind. Atoms of the same. So elements and compounds are what? Are considered pure substances. Class. What then is an impure substance? An impure substance is a substance that contains components of different kind. When you cannot place everybody that is in the substance, you cannot place them in one family. That substance is not pure. When every constituent that makes up the substance is not under one family, that substance is what? Is impure. Impure. And this is where we have mixtures. The mixtures are impure. Although, class, we have some mixtures that are pure. So actually, when I teach you mixture, I'll teach mixture as a topic. When I teach you mixture, I'll tell you that we have a homogeneous mixture and heterogeneous mixture. So if I'm to be actually very correct, I'll say that example of impure substance are heterogeneous mixtures. Heterogeneous mixtures. Heterogeneous mixtures. What are heterogeneous mixtures? These are mixtures whose components are of different kinds. These are mixtures whose components are of different kinds. So it means that even under pure substance, we can still place homogeneous mixture as a pure substance. Homogeneous. Homogeneous mixture is a pure substance. Because the components of homogeneous mixture are of the same kind. In fact, the word homogeneous means of the same kind. And the word heterogeneous means of different kind. Are you still following me? Are you still following me? The way I will run this class, after I teach a bit, I will give some classworks to stimulate you so you don't get bored. Are we together? Do you like that? After I teach someone, I give some classworks to stimulate you, right? So that you can be involved. We make the class interactive. Make the class interactive. If you are following me, say, sir, we are following you. I are with you, sir. If you are with me, say, sir, we are with you. Say, sir, we are with you. Say, sir, we are with you. If you are with me, say, sir, we are with you. We are with you. Excellent. Say, sir, we are with you. We are with you. Yes. Excellent. Yes, yes, yes. Excellent, excellent. Nobody has left. In fact, the numbers are increasing. This is good. 80 students joining us live. 80 students learning with us live. This is good. This is good. Everybody's active. If you leave, you're on your own. If you leave this class, you're on your own. Jamb is a competition. Everybody's active. Nobody has left. Nobody has left. If you leave, you're on your own. You are the one writing Jamb this year. You are the one that spent money on your Jamb form. If you leave, you're on your own. Everybody's active. Nobody has left. Make sure you're not the one that left the class. Everybody's active. Everybody's active. Well done. Well done. Well done. Well done. This is good. This is the best set. This is good. This is good. Class. So in pure substance of different kind. Pure substance of the same kind. Class. Let us have some questions. Class. Before I give you questions, let me say this quickly. There's what we call test for purity. Test for purity. Class. How can we test for the purity if a substance is pure or impure? Class. One of the ways we can know if a substance is pure or impure is by checking its boiling point. We can also check its melting point. Now, when checking the boiling point of a substance, what do you look out for? Class, a pure substance. Notes, you write down notes. Write in your notes. I hope you have a note. You are writing. I hope you're not just watching me. You have your book, you have your notes, you are writing, right? This is a live class. There's no difference between this class and a physical class. Because in a physical class, you still sit in your seat, right? And you're watching the teacher teaching, right? You see what I mean? You know what I'm teaching. This is the board. There's no difference between this class and a physical class. Because in a physical class, you also watch the teacher teaching, you'll be in your seat, right? So you're on your seat and I'm teaching. If you want to ask questions, you can ask on the comment section. You can also ask on our group. That's why we have a group, right? So there's no difference between this and a physical class. The same thing. Make sure you're writing. How do you test for purity, class? You can either use the boiling point of a substance or the melting point. What do you check out for in the boiling point? Look up, class. All pure substances have a fixed boiling point. Class, notes. All pure substances have a fixed boiling point. The moment the boiling point of a substance shifts from that fixed boiling point, once there's an increase in the boiling point, there's a level of impurity in that substance. Class, we all know that the boiling point of water is 100 degrees Celsius. Water boils at 100 degrees Celsius. Anything above 100 degrees Celsius tells me that that water is no longer pure. One of the easiest ways to test if water is pure or not is to check if the water boiled at 100 degrees Celsius. How do you know water has boiled at 100 degrees Celsius? Class, what is the boiling point of a substance? It is the point at which the liquid, if it's water, at which water starts turning to gas. The point at which water starts turning to gas. That's the vaporization point. Vaporization is the boiling point. What temperature does that water start turning to gas? If it is not 100, it means that water is not pure. All pure substances have a fixed boiling point. As soon as the boiling point starts moving from one point to another, it's no longer pure. And class, notes. For boiling point, if the substance is impure, the boiling point will increase. But for melting point, if the substance is impure, the melting point will reduce. So class, the higher the boiling point, the higher the impurity. Right now, it's a Jamb question. Class, the most toughest question in Jamb is not the calculation part. It's those theoretical parts that you wonder, where is this thing in my textbook? Have you seen some question in your Jamb exam and you wonder, where is this thing in, what topic does this question fall under in the textbook? I'm lost. What topic does this question fall under in the textbook? I am lost. What topic does this question fall under in the textbook? I am. Calculation is easy, you can take a formula, right? But questions like this, which of following is true of purity of substance? Note number one, the higher the boiling point, the what? The higher the impurity. The higher the boiling point, the higher the impurity. The higher the boiling point, the higher the impurity. Well done, class. Everybody is still here. Everybody is still here. Well done, well done. The higher the boiling point, the higher the impurity. But the lower the melting point, The lower the melting point, the higher the impurity. The lower the melting point, the higher the impurity. So class, increase in boiling point shows increase in impurity. But decrease in melting point shows increase in impurity. So class, what we can say here is that the level of impurity is directly proportional to the boiling point, but inversely proportional to the melting point. Hear me again. Hear me loud and clear. The level of impurity in a substance is directly proportional to the boiling point, but inversely proportional to the melting point. The level of impurity in a substance is directly proportional to the boiling point, but inversely proportional to the melting point. The level of impurity in a substance. The level of impurity in a substance is directly proportional to the boiling point, but inversely proportional to the melting point. One good thing about this live class is that everything that you are watching here is recorded. So all our friends can easily get the video again and watch again and again and again. So if you are lost somewhere, you can replay the video and watch in your own pace. This is one advantage the online class gives you. In a physical class, if you go to a physical class, if you don't understand anything that day has gone. You can't get it back. You can never get that day back. But in online class, all our live classes are recorded. They are recorded. What you have to do is that, sir, I missed that chemistry class. Can you send me the record? I will send to you. If you are our student, I will send to you. You can sit down and watch again. Very simple. Very simple. Now, we have just explained boiling and melting points. Let us take this question down. It's a Jamb standard question. Like I told you, I'll be stimulating you with questions in between my classes. That's what an experienced teacher does. A good teacher's class is never boring because I make sure that I stimulate your brain, I stimulate you. Class, let's go. Let's take this Jamb question down. This Jamb question said a pure substance. So a pure solid melts. Option A, a pure solid melts. Option A, over a wide range of temperature. A pure solid melts over a wide range of temperature. B, over a narrow range of temperature. C, you will tell me your answer in the comment section. C, at a lower temperature. At a lower temperature than the impure one. D, at the same temperature as the impure one. At the same temperature as the impure. Can you tell me your answer in the comment section? Can you tell me your answer? First answer. Let me know your answer in the comment section. A pure solid melts. A, over a wide range of temperature. B, over a narrow range of temperature. C, at a lower temperature than the impure one. D, at the same temperature as the impure one. Let me know your answer. Okay, someone said A. Someone said Chisholm said B. Someone said A. Someone said C. Interesting. Let me know your answer. Innocent said A. Raimat said A. Oseni said A. Titan said C. Chinaza Cynthia said A. I'm saying C. Drop your answer in the comment section. Drop your answer. I'm seeing your answers. Well done. C is the one popular. I'm seeing a lot of C. Class, let us dissect each of the answers. Let us dissect each of the answers. Class, remember that for a pure substance, once impurity comes into a pure substance, the melting point will drop. Once an impurity comes into a pure substance, the melting point will drop. So if this guy melts at 2 degrees, at minus 4 degrees Celsius, it will start melting at minus 8 degrees Celsius. There's a decrease in the melting point. Class, if it was boiling point, what happens if impurity comes into a substance for boiling point? The boiling point will increase. Impurities increases the boiling point of a substance, but reduces the melting point of a substance. Take notes, understand the difference. Impurities increases the boiling point of a substance, but reduces the melting point. So what does that mean? The impure substance will have a lower melting point than the pure substance. Class, so those of you say C is not the answer. Let me tell you why. Listen to the English. A pure solid melts. If you chose C, let us put it. A pure solid melts at a lower temperature than a pure one. No. Class, this is pure. Pure is minus 4. Impure is minus 8. Is minus 4 lower than minus 8? No. Minus 4 is higher than minus 8. So actually, a pure solid melts at a higher temperature than a impure one. A pure solid melts at a higher temperature than a impure one, not at a lower temperature. So C is wrong. You see how Jamb makes people fail their exam? This is a Jamb question. C is wrong. If you understand why C is wrong, say, I understand now, sir. Type in the comment section, say, oh, sir, I understand now. I understand now. This must be an interactive class. Say, I understand now. If you understand, say, I understand now. If you are still lost, let me know, I'll come again. If you understand now, say, I understand now. If you are still lost, say, sir, please, can you come again? Anyone, if you understand now, say, I understand now. If you are still lost, say, sir, can you come again? If you understand now, say, I understand now. If you are still lost, say, sir, please, can you come again? Okay. Anya who said, I'm lost, sir. I like your honesty. I like a student that is honest. Precious says, sir, please come again. I like this. I love this. Just be honest with yourself. Don't just be humble. Say, I don't understand, sir. Help me. I'll help you. I like this. Some people say, I understand. Say, sir, can you come again? Good. Sir, please come again. Good. I like this. Favor Pius says, sir, come again. I'm lost, sir. I will come again. I will come. Ulogu Mary, I'm lost, sir. Destiny, I'm lost, sir. I will come again. Ajibade say, I don't understand, sir. Good. Don't worry. I will come again. I will come. If I say, come again, sir. I'm lost, too. Abundance say, I'm lost, too. I will come again. Marvelous say, I don't understand, sir. Please, can you come again? I will come. Abundance say, I'm confused. I will come again. Ajoke said, I don't understand. I'm lost. I will come. Yes. Let me come again. Let me come again. Adejo Joy said, I'm lost. Let me come again. Someone says, because the lower the melting point, the higher the impurity. Correct. You are correct. You are actually correct. The lower the melting point, the lower the melting point, the lower the what? The lower the melting point, the higher the impurity. The lower the melting point, the higher the impurity. Some of you, this is what you use to choose C as the answer. Am I correct? This is the statement you use to choose C as the answer. But class, the lower the melting point, the higher the impurity. That means the higher the impure substance. But class, this question did not ask for a impure solid. This substance acts for a pure solid, not impure. A pure, not impure. This statement says the lower the melting point, the higher the impurity. That is the higher the impure substance, right? The higher the impure. But this is not impure, this is pure. So this pure will be opposite of what is here. And that makes this C wrong. Because some of you, I know I gave you this statement, and you just saw lower, and you saw C lower. You just went for C, no. That allowed Jamb to trick you. That some of you are very intelligent, but you will miss some funny, some tricky questions because of this. You allow Jamb to trick you. Be careful. Me, I'm very experienced, so they can't trick me. I'm experienced. I know all their tricks. Right, follow me again. Let me explain why this C is wrong. And to be honest with you, so I don't increase the level of suspense, B is the correct answer. B is actually the correct answer. Because it is clear that even D is wrong. A pure solid and an impure solid cannot have the same temperature, right? What would that be the difference? They cannot both melt at the same temperature. So D is also wrong. And A is wrong, and you know why A is wrong. When there is a wide range of temperature at which a substance melts, that substance cannot be pure. A pure solid usually melts at a very narrow or fixed temperature. I told you. It melts over a narrow range of temperature, very narrow. The more narrow it is, the more fixed it is. But the more wide it is, the more variable it is, class. B is the correct. If you got B, say I got it. If you got B, if you chose B, type I got it in the comment section. If you chose B, type I got it. But let me explain, let me keep explaining. Let me now explain why C is wrong. I'm going to explain why B is correct, right? Because a pure solid melts over a fixed or narrow range of temperature. Narrow, it must be narrow. If it is too wide, if it is melting at any temperature, you know that it's not pure. But a pure solid melts over a narrow range of temperature. Please take note. Now, why is C? I will not leave this question that I explain why C is wrong. Because people will never be happy and satisfied if I don't explain why C is wrong. Am I correct? And I want to make my students happy. My goal is to make my students happy and satisfied. Follow me. Why is C wrong? Because class, as I told you, if a pure substance melts at -4 degrees Celsius and an impurity comes into the substance, impurity reduces the melting point. The lower the melting point, so the higher the impurity. So impurity lowers the melting. Now, if you are going for -4, what is the lower number after -4? Hope you don't think it's -3. Oh. -3 is not lower than -4 in the minus category. One after -4, the lowest place is -5, then -6, then -7, then -8. So class, the impurity coming into a pure substance will drop the melting point to -8. So melting point has reduced from -4 to -8. So class, and this thing that happened there makes this C wrong. Why? A pure solid melts at a lower temperature. No. A pure solid melts at a higher temperature than the impure one. A pure solid melts at a higher temperature than the impure one. This is pure, this is impure. -4 is higher than -8. The temperature for the pure substance is -4. But the temperature for the impure is -8. -4 is higher than -8. So a pure solid melts at a higher temperature than the impure one, not at a lower temperature. That's what makes C wrong. So a pure solid melts at a lower temperature than the impure one is wrong. Is what? Is wrong. I hope I've been able to convince you and not to confuse you in this aspect of melting points and impurity. Let me know what's going on in the comment section. Let me know your thoughts. What's on your mind in the comment section? Let me know your thoughts. I love this class. Nobody is confused. Nobody is confused. Everybody is following. Well done. Everybody is following. Everybody is following. This is good. This is good. This is good. This is good. Okay, someone say, I got it now. I got it now. Yes, I understand now. Excellent. Thank you, sir. I understand now. I understand now. Good. Very good. Very good. Hey, someone said another question on it, sir. Another question on it, sir. Udochukwu said, I got it, sir. Well done. Udochukwu said, I got it, sir. Well done. Someone said, sir, another question. Sir, another. Okay, yes, I understand now. More questions, please. Good. More questions, please. Good, good. Another question, another question, another question. Another question, another question. Another question. The presence of an impurity in a substance will cause the melting point to A. The presence of an impurity in a substance will cause the melting point to A. Increase. B. Be stable. C. Be zero. D. Reduce. Everybody should get this. Everybody should get it. Let me know your answer in the comment section. Everybody should get this. Let me know your answer in the comment section. Some people say increase, some people say reduce, some people say... People are saying A, some people are saying D. The presence of an impurity in a substance will cause the melting point to... Let me know your answer. Everybody saying D, 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 D. Someone is saying A. Marvelous said A. Okay, so we don't waste much time. Let me continue. Class, the answer is D. Those choosing A, this A would have been correct if the question was boiling point. If the question was boiling point, impurity increases the boiling point but reduces the melting point. Please don't forget. That's why it's good I give questions so that even if I taught something I don't understand, or maybe you misunderstood me, when I give question and you miss it, you will never forget that thing again. It's the teaching pattern. It's a teaching pattern. And that's why anytime I teach students, they don't usually want anybody to teach them again. That's the problem. Anytime I teach a student, they don't want anybody to teach them again. That's my problem. The other day I sent a mathematics teacher to come and teach myself, so people were just complaining. And it's an issue because once I teach students, they don't want anybody to teach them again. But please, because when I teach, I make sure that you understand. I give questions to make sure you still follow up. Class, so I said, the presence of an impurity in a substance will cause the melting point to do what? To reduce. But it will cause the boiling point to increase. Impurity causes the boiling point to increase, but cause the melting point to reduce. Impurity causes the boiling point to increase, but cause the melting point to reduce. One more question and then we'll go forge ahead. One more question and we'll forge ahead. Let's go. One more question we'll forge ahead. A substance is said to be impure. A substance is said to be impure If A its melting point range is wide, if its melting point range is wide. B, if it dissolves in water with difficulty. C, has a low melting point. D, it is colored. Class, what's the answer? Tell me in the comment section. Let me know your answer in the comment section. Let me know your answer in the comment section, class. Oluwakemi says C. Abundance said A. Perez said A. Favor Kike said D. Precious said A. Baliki said A. I'm seeing D. I'm seeing A. Let me know your answer. Let me know your answer in the comment section. Good. It means you are following. It means you are following. It means you are following. Well done, class. If you are typing, well done. If you are dropping a comment, well done, well done, well done. If you are dropping a comment, well done, well done, well done. Class, the answer is A. A substance is said to be impure if its melting point range is wide. Class, a wide melting point range shows that the substance is impure. What then shows that the substance is pure? A narrow melting point range. Class, this question is the opposite of the first question I gave you today. Do you agree? This question is the opposite of the first question I gave you today. Do you agree? If you agree, type I agree. If you agree, type I agree. This question is the opposite, direct opposite of the first question I gave you today. Because in the first question we talked about a pure substance melts at a narrow range of temperature. But an impure substance melts at a wide range of temperature. At a wide range of temperature. Class, it's now time to look at elements, compounds, and mixtures. Elements, compounds, and mixtures. If you have never been good in chemistry, this is your opportunity to learn chemistry from the foundation again. If you are in this class, I just want to help you because I wanted to start from the scratch, from the beginning with us, from the foundation. Yes. Because when they hear online class, they think it's scam. When they hear online class, they think they want to scam them. At least, this is not a scam will not be teaching for 2-3 hours. It's not possible. A scam will teach chemistry for 3 hours on live. It's not possible. Are we together? So this is a real class. This is my board. This is my house. This is my house. I teach live. I'm a teacher. I'm a born teacher. I didn't start this work today. Is there anybody that has board in their house? I have a big board. Look at the board. I have a keyboard stand that's recording this video. I have a lot of tools that I use. Are we together? I make sure there's light, there's electricity, there's data to make sure I teach my students they pass. It's a live class. I used to do physical class before, but I have students from different states. How will I gather everybody in one place? If I say everybody come from Lagos, come from Abuja, where will I put everybody? I don't have an hostel. So I have to teach you online. but we are not a scam. We teach life. You see my face every day. Are we together? On Tuesday, you see me teaching physics. The only subject I give away is English because we have a specialist teacher that teaches English. But my science courses, you see me teaching it live on the board. This is my board, the Jamb Master. So if you're watching this video, you are here to enroll with us. Maybe because you are doubting. Stop doubting. You cannot learn Jamb under me and write Jamb again. I will not allow it. You cannot learn Jamb under me and repeat Jamb again. It's not possible. And they will not change your course. I don't allow it. We have that grace in our class. You will not change your course. Many of you have friends that are in school already, leave them. But they did not get the course they applied for. You will get that course you applied for. That will be your advantage. Delay is not denial. Delay is not denial. You get the course you want this year. Let's go, let's go, let's go. Let's go. I'm talking too much. Let's go. This is not time for talk. I came here for serious business. Elements, compounds, and mixture. Let's go. I'm not here to joke at all. I'm not here to joke. I'm not here to joke. Elements, compound, and mixture. Elements, compound, and mixture. Let's start with elements. Class, this is the foundation of everything in chemistry. Class, there's no topic in chemistry that you will not deal with elements. So why you are struggling in that big topic in chemistry, why you are struggling there is that you have not fully understood this aspect. By the time I'm done with this topic, some of you will know that you actually go and ask for your school fees back. Because some secondary schools do not try at all. Some secondary schools do not try at all. Some of you are very intelligent, you are smart. If you remember very well, in primary school, you don't read too much, but you pass. When you're in primary school, you don't read too much, you pass. Do you remember? You pass all your exams. You don't write common entrance twice. Nobody even goes for tutorial for common entrance. You wrote for common entrance once. You were very intelligent. What happened? Most Nigerian secondary schools are not equipped enough to teach students, to make them good students. It's not actually your fault. You are smart, you are intelligent. Many of these teachers that did not teach it well, they did not break these things down for you well. This is the foundation of chemistry. Nobody, anybody that teaches you chemistry did not start here. Please run away. Because anything that once the foundation is destroyed, nothing else can happen. Elements, write down. An element is a substance. Write down. An element is a substance. An element is a substance which cannot be split. An element is a substance which cannot be split into simpler units by ordinary chemical process. An element is a substance which cannot be split into simpler units by ordinary chemical process. Someone say, come again, please. It's on the board. It's on the board. It's on the board. An element is a substance which cannot be split. Someone said, I go collect my money back from all these teachers. Yes. Some of you were cheated in your secondary. They cheated you in your secondary. They did not teach these things well. They did not teach it well. Someone says, just like I'm under chemistry for the first time. Good, good. I'm glad you're learning. Yes. It's just like I'm under chemistry for the first time. Yes, exactly. An element is a substance which cannot be split into simpler units by ordinary chemical process. An element is a substance which cannot be split into simpler units by ordinary chemical process. Note, they are the building blocks of all other substances in chemistry. They are the building blocks of all other substances in chemistry. They are the building blocks. They are the building blocks of all other substances in chemistry. Elements are the building blocks of all other substances in chemistry. Class, as it stands now, do you know there are 110 known elements currently? How many elements did they tell you there are in your secondary school? Tell me the truth. How many elements, when you finish secondary school, how many elements were there when you finished secondary school? What did your teacher tell you when you were in secondary school? How many elements do we have in the whole world? When you were in secondary school, how many elements did they tell you from secondary school? Let me know. Type in the comment section. How many elements were you told? Because every day they are discovering new elements. Are you aware? Every day they are discovering new elements. They told you 20K. Someone said 30. Someone said 40. Someone said 20. In your school, they told you 40. Someone said 40. Class. As a matter of fact, we have 118 elements. It was 110 before, but discovered 8 more. 8 more elements were discovered in chemistry. Every day, science is evolving. Some of the chemistry they taught you in your secondary school, they have updated the iOS. Science is an evolving study. It's an evolving discipline. We now have 118 known elements. 118 known elements in chemistry. 118 known elements in chemistry. Someone said, I'm so happy I joined this class. Peculiar. This is good. This is good. I'm happy. This is good. This is good. Someone said chemistry is a stumbling block for me. Don't worry. After this, you will see your Jamb score this year in chemistry. Someone said we even used to sing. Go okay. Ajoke said we even used to sing. Okay. Class. There are 118 known elements in chemistry, but class, I will not blame your teacher too much if they told you there's only 20. I will not blame your teacher too much if they told you there's only 20. Do you know why? Because out of the 118 elements, the most commonly used elements is the first 20. Class, from secondary school till Jamb, the only question I will ask you in Jamb is from the first 20 elements. So under your scope of study, there was only 20 elements. But class, generally know that there are 118 known elements in chemistry. As soon as you step into 100 level, I teach 100 level students. If you check my YouTube channel, you will see me teaching a lot of 100 level students. I teach in the University of Port Harcourt. If you have a friend in the University of Port Harcourt, ask them of success tutorials. I'm well known there. For those that are doubting, if you just call your friend in Uniport, do you know this man? Is he legit? Call and ask. We are not hiding. This is our face live. A scam will not show his face live. Look at my face. Screenshot it. Post it anywhere. I'm a live teacher. If you have any friend in the University of Port Harcourt, call. Ask. Do you know this man? Look at him. He was teaching me chemistry. Do you know him in Uniport? Does he teach in Uniport? Ask anybody in the science field. I teach science. I don't teach art and commercial in the science in Uniport. I teach science. There's nobody that finished from University of Port Harcourt in science that does not know Mr. Success. Mr. Success. Ask anybody. It's not possible. I beat myself and I tell you, ask anybody for those doubting. Now let's go. You should bother about only the first 20 elements, class. For Jamb, we'll not ask you a question more than the first 20 elements. Class, if you're a chemistry student here and you cannot state the first 20 elements without blinking your eyes, if you are sleeping and they wake you up and they say state the first 20 elements, if you cannot do it, something is wrong somewhere. If you are sleeping and they wake you up and they say state the first 20 elements and you cannot do it, something is wrong somewhere. If you are watching me now and you can state the first 20 elements and you will not blink your eyes, type yes. Type yes. If you cannot state the first 20 elements, say, sir, please help me. If you can state the first 20 elements without blinking your eyes, without missing anyone, in their correct position, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, potassium, calcium, I would say back to back. Type yes. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. You can state the first 20 elements. Say, yes, sir, I can. If you cannot, say, sir, please teach me. Sir, teach me. If you cannot, don't be humble. Just say, sir, teach me. I'll break it down for you. If you can state the first 20 elements without blinking your eyes, type yes. If you cannot, say, sir, teach me. Good. Everybody's saying yes. Good, good. Someone says, sir, please help me. Oh, damn, we have many smart students here. Almost everybody can do it. Someone says, sir, my cousin told me about you. That's how I know you. Thank you. Thank you. Sir, my cousin told me about you. That's how I know you. Good. Ask anybody in University of Port Harcourt. Do you know Mr. Success? Ask anybody. Someone said, but I know fit arrange and well. Okay, let us do the first 20 elements. This is the foundation of chemistry. Let us do the first 20 elements. hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. When teaching my 100 level students, I don't ask for 20, I increase the level. My 100 level students, I ask for 30. You must be able to state the first 30 elements. But for Jamb, 20 is okay. If you are here and you put University of Port Harcourt in your Jamb university, you will meet me in 100 level. I will teach you, I will lecture you in University of Port Harcourt. You will still meet me in 100 level. For those that put University of Port Harcourt, if you also put Rivers State University, RSU, you also meet me, I teach there too. I lecture there too. So if you put University of Port Harcourt, you will see me, I will lecture you in 100 level. If you put Rivers State University, I will also lecture you in 100 level. Because I lecture university that's the University of Port Harcourt and the Rivers State University. Someone said, my sister told me about you. Good. So if you put any of those schools, I'll still teach you in 100 level. So you meet us again after your Jamb. So our journey does not end here. Some of you will still teach you for post-UME. And after your Jamb, you have post-UME, right? I'll still help you pass your post-UME too. Don't worry yourself. After you have passed your Jamb, only you will come back and say, sir, teach me for post-UME. Sir, help me break down post-UME. Okay, now let's go. These are the first 20 elements. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. First 20 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Follow me. Class, it is important that you place these elements in their correct positions. Do you know why? Because I'm about diving into something else now. It's important that you place these elements in their correct positions. Why? Because each of these elements you're seeing here, the position matter a lot, class. Because every element is made up of what we call atoms. Every element is made up of what we call, everybody type atoms. Type atoms in the comment section. Let me know you are still with me. Type atoms. Atoms. Type atoms in the comment section. Type atoms. Type atoms. Type atoms in the comment section. Every element is made up of atoms. Every element is made up of atoms. Type atoms in the comment section. Type atoms in the comment section. Type atoms. Type atoms. Type atoms. Type atoms in the comment section. Every element is made up of atoms. Class, before now we're told that atoms are the smallest indivisible particle of an element. Am I correct? We were told that atoms are the smallest indivisible particles of an element. Class, indivisible means that the atoms cannot be divided. But class, after the modification of Dalton's atomic theory, you know we have the original Dalton's atomic theory in chemistry. Then we have the modification of Dalton's atomic theory. After the modification of Dalton's atomic theory, we now found out that atoms are actually divisible. And atoms are not the smallest particle of an element. Before now, we knew that we used to say atoms are the smallest indivisible particle of an element, right? But class, atoms are not the smallest indivisible particle. Because indivisible means that atoms cannot be divided, right? But class, atoms can actually be divided. So you see that science evolves every day. You can know one thing tomorrow and it changes next tomorrow. That's why you should not be too proud and say, I know everything. Things change every day in science. They are discovering new things and new things. Do you hear when they discovered a new planet? Before we know the Venus, Uranus, we know Jupiter, right? You know Plato, you know the Earth. They discover new planets every day. Science is evolving. So class, atoms are not indivisible. Class, atoms are divisible. Atoms can be divided into three particles. Atoms can be divided into three particles. Proton, neutron, and electrons. Follow me. Before my students started calling me the Jamb Master, I did not give myself that name. I'm Mr. Success. I am Mr. Success. But my students says the Jamb Master. When they saw their results, when they saw their Jamb results, they said the Jamb Master. Follow me, you know why. Atoms are divided into protons, neutrons, and electrons. Atoms are divided into protons, neutrons, and electrons. So they are divisible. They are what? Divisible. Why am I mentioning this, class? Every element here is made up of atoms. And therefore, every element here is made up of protons, neutrons, and electrons. Every element here is made up of atoms. And every element here is made up of protons, neutrons, and electrons. Class, these three particles are found in every element in the periodic table. The protons are the positively charged particles. They are the one positively charged. The electrons are negative. Electrons are what? And the neutrons are neutral, uncharged. So every element here contains positive particle, proton, neutral particle, neutron, and negative particle, electron. Every element here contains what? Positive particle, proton, neutral particle, neutrons, and negative particle, electrons. Class, follow me carefully. Class, another thing you must do, a good chemistry student must be able to state the number of proton, neutron, and electron for the first 20 elements. Class, if they wake you up for a very sweet deep sleep, and they say, what's the number of proton, neutron, and electron for potassium? Without thinking, you should tell me. Without thinking, you should tell me. Because Jamb rewards speed. Don't forget the speed arc I taught you in the live session. The Jamb CBT speed arc. You can be intelligent but slow and you fail Jamb. You must be fast. You must be on your toes. I teach my, that's why every week we are doing mock tests. Every week we are writing mock tests. When is the day for our mock test? Type in the comment section. Let me see if you are following me. What day did I say we are doing mock tests every week now? What day is our day for mock test? Type in the comment section. Let me see if you remember. Let me see if you are serious. What day did we say is the day for mock test? What day is the day for mock test? What day did we say is the day for mock test? Every week in the Jamb Master class, you are writing mock test. Every week in the Jamb Master class, you are writing mock test. You must pass. We are going to force you to pass Jamb. We are going to force you to pass Jamb. Even if you don't want to pass, you must pass. Friday, every Friday is mock exam. Every Friday is mock exam. So Friday is not for learning, it's mock exam. Sunday we learn chemistry. Monday we learn English. Tuesday we learn physics. Wednesday we learn biology. Thursday we learn mathematics. Meaning that we have learned all the subjects, right? Friday we then write mock exam. There's no class that does it like this. Organized like this. There's no way you will not pass. You must pass your Jamb. Now let's go. I'm going to give you a simple method of knowing the proton, neutron, and electron for the first 20 elements. I'll be giving you a simple method of how to know the proton, neutron, and electron for the first 20 elements. Follow me carefully. How to know the number of proton, neutron, and electron for the first 20 elements. Let's go. Class, before we do that, you must understand that's what we call atomic number and atomic mass. Atomic number and atomic mass. We have just told you now that every element contains atoms, right? And atoms are divided into protons, neutrons, and electrons. But class, I want you to quickly write down atomic number. 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 As we're getting closer to Jamb, I'll be increasing my hours of class. So get ready. I should teach 6 hours straight. Ask your senior colleagues. Don't worry, I'll bring some of my senior colleagues that taught Jamb. Let them come and give you the way I teach. As we're getting closer to Jamb, I'll be increasing the number of hours because I must cover your syllabus. You must clear your Jamb. I'll be increasing the number of hours. So this 4 hours is even small. I'll be increasing the number of hours. We're going to have marathon sessions. When we're getting very close to Jamb, I'll organize a Jamb camp. A Jamb online camp. You know what camp? When you go for camp in church, camp. We're going to have a Jamb online camp. When I mean online camp, no TikTok. That period, everybody delete your TikTok, delete your Facebook, delete your WhatsApp. Only, okay, being on your WhatsApp because we need to be communicating on our group. Delete everything because we want to pass our Jamb. Jamb online camp. When we're getting close, when it's 1 month to Jamb, I'll open another group called the Jamb online camp. Class, I'm going to camp. Anybody that join that camp, if you score less than 280. Jamb online camp, where we are going to coach you separately, because we're not paying again. If you are paying for the class, you're not paying again. If you are paying for the class, you're not paying again. You are enjoying that camp too. Are we together? Where we're going to be increasing the number of hours. We increase the number of hours and coach you. If you must be in that camp, you must give us proof that you have deleted your TikTok. You have deleted you download it back, Instagram, all those things, delete it. Pass your Jamb first. When you enter school, you can enjoy TikTok where you're not in university. Nobody will disturb you again. When you enter university, you can install your TikTok, your Facebook. The Jamb camp, what happens in the camp? In the camp, you focus. When boxers are preparing for boxing, do you know how they go for camping? They don't stay with their family, they go for camp, 3 months camp. I have a friend that is a boxer. They go for camp. They don't stay with their family for that period though. For that 3 months, when they have a fight, a serious fight, they don't stay in the house. They go and stay with their family. They go and stay with their coach. They rent a separate place. Even musicians, when they want to release an album, do you know that they have what called music camp? They rent a apartment where they will be producer, they will be director, there will be everything there. A keyboardist. And they are there for 1 month producing the album, different music. We are going to have a Jamb camp where we'll be producing your 300 in Jamb. We're going to be producing your 300 in Jamb. You will delete your TikTok, your everything. Let us focus. Every day we are bombarding you with questions. We are bombarding you with questions. At a point, almost every day we're writing mock exam. Every day we're writing mock exam. You must pass this Jamb. So some of you that thought I was not serious, I was just laughing at you. Some of you that thought we were a scam, I was just laughing. You don't know who you are dealing with. You don't know who you have met yet. Let's continue. Now, atoms, proton, neutron, and electron. Proton, neutron, and electron. Class, as I was saying, atomic number is number of protons present in the nucleus of the atom of an element. Atomic number is the number of protons present in the nucleus of the atom of an element. Atomic number, number of protons present in the nucleus of the atom of an element. Number of protons present in the nucleus of the atom of an element. Number of protons present in the nucleus of the atom of an element. Number of protons present. Number of protons present in the nucleus of the atom of an element. Number of protons present. Number of protons present in the nucleus of the atom of an element. Someone said I was once scared of chemistry, but I can now face my fears with zero fears in me. Good. I love testimonies like this. Good. These are how students are testifying about our class. So when we post, people think it's fake. Sure, you are saying that it's real. People are once saying it, that I cannot face chemistry before, now I can face it. So when I post this, now someone will think that I generated this. Meanwhile, it's happening live. You see, people are saying it by themselves. If I teach you, you want to testify by yourself. When I post it, some people will just think you are posting fake things. Don't know that it's real. This is students talking. That's how I like your class. This. Good. Someone say, I love this, sir. It's a testimony. This is a testimony. If I post it, someone says, sir, are you sure it's someone that said this? This is happening live now. Someone is saying, I love this, sir. So say, I've known you since 2016. Thank you. Maybe someone directed you to me. Thank you. Good. I love this, sir. I was once scared of chemistry, but now I can face my fears. Good. I'm happy. I'm very happy. Our Jamb camp is coming up. Our Jamb camp is coming up. Our Jamb camp is coming up. Atomic number, let's go. Sir, can you teach on how to balance equation? We are getting there now. I will break down everything. Some of you are just impatient. You don't know who you have met yet. How to balance equation, I will teach it very well. I will teach everything. This is the beginning. Let's not jump. Let us not jump. I will teach everything. There's a time we'll get to balancing of equation. I will teach you the algebra method, the half reaction method, how to balance ionic equation. What do you call ionic equation? I will teach you. Don't worry yourself. I will teach you balancing of equation. Don't worry yourself. Let us not rush it step by step. You're already in the class. Everything will be covered. Don't worry yourself. Atomic number. Someone say come again. Atomic number is number of protons present in the nucleus of the atom of an element. Atomic number is number of proton present in the nucleus of the atom of an element. Number of what? Proton. Class. When you have let's say we have an element X. Let X be an element. Let X be an element. Class, the atomic number of an element is represented with the symbol Z. Class, write down. The symbol for atomic number is Z. Z. The symbol for atomic number is Z. Z. And it is written as a subscript. Atomic number is written as a subscript. Class, what is the meaning of subscript? That means written under. Atomic number is written under. When you write an element, the number you see below is the atomic number. But the number you see above is the atomic mass. So don't confuse it. Atomic number is written as a subscript. Hope you are writing down. And the symbol of atomic number is Z. The symbol for atomic number is Z. And it's written as a subscript. The symbol for atomic number is Z. And it's written as a subscript. The symbol for atomic number is Z. And it's written as a subscript. Is the number of protons present in the nucleus of the atom of an element. Now let's go to atomic mass. Let us go to atomic mass. Make sure you don't get tired. This is a marathon class. You see I'm moving about. I'm in that mood now. When I enter that mood, you'll be the one that will be tired self. You don't know what you're about. Don't worry. Let me not talk much. Let me not talk much. Okay, atomic mass. Atomic mass is the number of proton and neutron present in the nucleus of the atom of an element. Atomic mass is the number of proton and neutron present in the nucleus of the atom of an element. Atomic mass is the number of proton and neutron present in the nucleus of the atom of an element. Atomic mass is the number of proton and neutron present in the nucleus of the atom of an element. Atomic mass is the number of proton and neutron present. Proton and neutron present. Proton and neutron. Proton and neutron present. Proton and neutron present in the nucleus of the atom of an element. Note, atomic mass is written as a superscript. Atomic mass is written as a superscript. Atomic mass is written as a superscript. Someone said, I'm rest assured with you. Thank you. Perez said, I'm rest assured with you. Thank you. Thank you. You must pass your jam. Someone said, I'm ready for the camping. That's the spirit. That's the spirit. I just like this set. I like this set. I don't know. I like the vibe of this set. There's no way a set will be. You just like the vibe. I like the vibe of this set. Everybody's just active. This is my most active. I love very active set. Very active set. Okay, so I trust you on that. Thank you. Thank you. We will not fail you. We will never fail you. I cannot. If you fail, I failed. So I cannot fail you. Atomic mass is written as a superscript, and the symbol for atomic mass is A. The symbol for atomic mass is A. So the symbol for atomic number is Z, and the symbol for atomic mass is A. Symbol for atomic number is Z. Symbol for atomic mass is A. Symbol for atomic number is Z. Symbol for atomic mass is A. Symbol for atomic number is Z. Symbol for atomic mass is A. Atomic mass is written as a superscript. If this is an element, the atomic mass is written as A on top. Atomic mass is written A on top, you can see. So why atomic number is written as a subscript? Someone says sub what, sir? Subscript, subscript. Subscript on the board. Subscripts. And superscripts. Who is written as a subscript? Who is a superscript? Right? Let me know in the question. Who is subscript? Who is superscript? Let me know in the comments. Who is subscript? Who is superscript? Who is written as a subscript and who is written as a superscript? Let me know in the comment section. Who is written as a subscript? Who is written as a superscript? Someone says, please go again with the last explanation of atomic mass, please. I'll come again. Atomic mass is number of proton and neutron. Atomic mass is number of proton and neutron present in the nucleus of the atom of an element. Atomic mass is number of proton and neutron present in the nucleus of the atom of an element. Atomic number is subscript. Subscript atomic number. Sub means under, below. Subscript means below. Subscript means below. Superscript means above. Subscript means below. Superscript means above. Subscript means below. Superscript means above. Class, it's now time to explain to you how do you easily get the atomic number of an element. How do you easily get the atomic number of an element, class? By arranging these elements in this order. Do you know that we have gotten the atomic number already? Class, it is important that when you are stating the first 20 elements, you don't misplace any of the elements. Class, carbon is number 6, nitrogen number 7, helium number 2, lithium number 3. The position matters a lot because it will help you to automatically know the atomic number. And what's the atomic number? Atomic number is number of protons. Atomic number is number of protons present in the nucleus of the atom of an element. It will help you to automatically know the atomic number easily. So class, stating the first 20 elements in the correct order is super important. Because automatically, it helps you to know the atomic number of each element. It helps you to know the atomic number of each element. It helps you to know the atomic number of each element. It helps you to know the atomic number of each element. Class, follow me. Let's go. So if they ask you what is the atomic number of hydrogen, you say 1 because there's any hydrogen, you place it in the correct place. But imagine you are starting the first 20 elements and your hydrogen was number 6. It means that you will be thinking that the atomic number of hydrogen is 6, right? That's why I said it's important. I started this class by saying it's important that you are able to state the first 20 elements in the correct order. It's important that you are able to state the first 20 elements in the correct order. So class, by doing this, you have used a stone to kill 2 birds. Because you now know the atomic number of each element. And you also know the number of protons. The atomic number means number of what? Protons. Follow me. So if I ask you now, class, follow me. What is the atomic number? Let me see if you are still following this class. Or you just put the phone on play and you are doing something else. Let me see if you are watching. Those that comment now, I will know those that are watching and following the class. Those that comment now. Someone that is not following will not comment immediately. What is the atomic number, class, of argon? Type it. First to comment in the comment section. Let me see who is active. What is the atomic number of argon? 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 Good. Abundance said 18. Good. What is the atomic number of argon? Good. Second to comment, Pinky Bella said 18. Precious, I love this. Everybody's talking. I love this set. Precious, everybody's talking. This is good. I love this set. This is very good. Everybody is commenting. This is very good. Everybody says something. I just like this set. 18, 18, 18. Nobody's sleeping. Nobody's tired. Everybody, nobody's saying my battery is low. Nobody's saying my data, oh, my data. Oh. This is good. I like this set. I like this set. This is good. This is good. This is good. 18. It means you are following. Do you see why it's good to state the first 20 elements in the correct order? What if when I was stating the element, I went to put argon in number 16? You see? So when it says take the first 20 elements, don't just mention them scatteredly. Mention them in the organized way. So that it can help you to know the atomic number. Okay, hydrogen 1, helium 2, lithium 3, beryllium 4, boron 5, carbon 6. Do you get the idea? Good. That's atomic number for you. Now let's go to atomic mass. Plus, atomic mass is not easy as atomic number. For atomic mass, it is number of proton and neutron. For atomic mass, it is number of proton and neutron. Class, I'll give you an easy way of knowing the atomic mass of elements. Let me give you a very easy way. Are you aware that from atomic number, you can easily get the atomic mass of an element? Why we are doing that? Let me remind you that the symbol Z represents atomic number, right? I told you that the symbol for atomic number is Z. and the symbol for atomic mass is A. Who can tell me another name for atomic mass? Type in the comment section. Who can tell me another name for atomic mass? Type in the comment section. What is another name for atomic mass? First answer, first answer. Who can tell me? Let me see my best in Jamb this year. Let me see my best in Jamb this year. Let me see my best in Jamb this year. What's the name for atomic mass? Let me see my best in Jamb. Excellent. I like this set. I like this set. I like this set. Excellent. 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 Another name for atomic mass is mass number. 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 So another name for atomic mass is what? Mass number. Good. Excellent. 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 So I was about telling you a very easy way of determining the atomic mass from the atomic number, class. I want to give you a simple way of how to know the atomic mass of an element using the atomic number. We all agree that all these numbers there are the atomic numbers, right? You agree, right? The numbers below here, they are the atomic number. Don't forget, we say atomic number is written as a subscript below. Atomic number is written as a subscript below. You can see that some of them are below. Below. But there's another number that will come above, superscript. There's another number that will come above, super. That's the atomic mass. How do you get the atomic mass of an element without cramming? Without my chemistry students, if I ask you what is the atomic mass of potassium, you don't need to think twice, 39. What is the atomic mass of aluminium, 27? What is the atomic mass of sodium, 23? Don't think, don't think. What is the atomic mass of potassium, 39? What is the atomic mass of fluorine, 19? Don't think. Oxygen, 16. Don't even think twice. Carbon, 12. Don't even think twice. Boron, 11. Are we together? Nitrogen 14. Are we chlorine 35.5? Chlorine 35 points. I want to push you to that extent that when they ask you, just say it. It's just like it's AI that's talking. I want to turn you to an AI chemistry machine. I want to turn you to an AI chemistry machine. When they ask you a question, just answer yes. Are we together? Let's go. How do you get atomic mass and atomic number? Class, there are two ways. When the atomic number is even, when the atomic number is even, it's something you will do. And when the atomic number is odd, we all know what is even number and odd number, right? We all know what is even number and odd number from your secondary school. We all know what is even number and odd number. Class, we all know that an even number is a number that is divisible by 2. An odd number is not divisible by 2, right? An even number is divisible by 2. An odd number is not divisible by 2. Class, how do you know the atomic mass of an element? From the atomic number. When the atomic number is even, just multiply it by 2, you have the atomic mass. Follow me carefully. When the atomic number is even, multiply by 2, you're going to have the atomic mass. When the atomic number is even, multiplied by 2, you're going to have the atomic mass. When the atomic number is even, multiplied by 2, you have atomic mass. When the atomic number is even, multiplied by 2, you have atomic mass. When the atomic number is even, multiplied by 2, you have atomic mass. Let us apply. Who is the first even atomic number? 2. Helium has an atomic number of 2. So what will be the atomic mass of helium? 2 times 2, 4. Beryllium 4, 4 times 2, 8. Carbon 6, 6 times 2, 12. Very simple, easy. 8 times 2, only for even numbers. Notice I'm skipping the odd numbers. I'm skipping the odd. There's another rule for odd numbers. When the atomic number is odd, I will tell you what to do. When the atomic number is even, multiply by 2. 12 times 2, 14 times 2, 28. 16 times 2, 30. 18 times 2, 36. 20 times 2, 40. If you are following me, say, sir, I am following. If you are following me, say, I am following, sir. If you are following me, say, I am following, sir. If you are following me, say, I am following, sir. If you are following me, say, I am following, sir. I am following, sir. I I am following, sir. If you are following me, say I am following, I am following, I am following. Good, good. I like the energy in this set. I love the energy. I love the energy. This is good. Everybody is following. Everybody is following. Everybody is following. Someone says, sir, please come again. So you say, I'm reading all your comments so I can know how to teach you and how to help you. I'm reading all your comments so I can know how to teach you and how to help you. Let me come again. I said, if the atomic number is even, to get atomic mass, multiply the atomic number by 2. Multiply the atomic number by 2. So, when the atomic number is even, who are the atomic numbers? The numbers below, right? All the numbers below are atomic numbers. When they are even, multiply by 2. 2 times 2, 4. 4 times 2, 8. 6 times 2, 12. 8 times 2, 16. 10 times 2, 20. 12 times 2, 24. 14 times 2, 28. 16 times 2, 32. 18 times 2, 36. 20 times 2, 40. So that's even. Let's go to odd now. Let's go to odd. When the atomic number is odd, what do? Multiply by 2 and add 1. When the atomic number is odd, multiply by 2 and add 1. When the atomic number is odd, multiply by 2 and add 1. When the atomic number is odd, multiply by 2 and add 1. Why am I repeating it? So that those who know the life, input network determines where you have met us, right? So I'm repeating so you can write and gain. When the atomic number is odd, multiply by 2 and add 1. When the atomic number is odd, multiply by 2 and add 1. Class, but there are some exceptions. For the odd number rule, there are some exceptions. Who are the exceptions? Hydrogen. Hydrogen does not obey the rule. Nitrogen does not obey the rule. And chlorine does not obey the rule. Please take note. Hydrogen, nitrogen, and chlorine do not obey the rule. Hydrogen, nitrogen, and chlorine do not obey the rule. Hydrogen, nitrogen, and chlorine does not obey the rule. Someone say, please, sir, record the video. My network is disturbing. It's automatically recorded. This class is automatically, this is a live class. So YouTube is automatically recording it. This is a live class. So YouTube is automatically recording the video. You don't have nothing to worry about. If you are my registered students, just after this class, message me, sir, please, can I have a link to the video? If you are my registered student, I will send to you. This is an advantage of an online class. Even if you don't understand some things I'm saying, you can go and rewatch. In a physical class, you don't have that advantage. Once the class is over, it is over for that day. But in an online class, you can go and rewatch again and again and again. This is the advantage of online class. So class, these three elements do not follow the rule. Hydrogen, nitrogen, and chlorine. These three elements do not follow the rule. Class, can you still see the board? Can you still see the board? Can you see the board clearly? Can you see the board clearly? You can see the board, right? Can you see the board? I hope you can see the board. Good, good, good. Okay. So class, these three elements do not follow the rule because the atomic masses are, hydrogen is 2. If it was to follow the rule, 1 is an odd number. 1 times 2, 2. 2 plus 1, it will have been 3. But it doesn't follow the rule. What did I tell you about odd number? When the atomic number is odd, multiply by 2 and add 1. When the atomic number is odd, multiply by 2 and add 1. When the atomic number is odd, multiply by 2 and add 1. But these three elements do not follow the rule. So I will just asterisk them. Hydrogen is just 2. Nitrogen is 7 times 2, 14. Normally, if I'm to follow the rule, it's 14 plus 1, 15. But no, it doesn't follow the rule. And chlorine exhibits what we call isotopy. So the atomic mass is 35.5. Chlorine is 35.5. It doesn't follow the rule. It doesn't follow the rule. If it was to follow the rule, you say 17 times 2, 34. 34 plus 1, 35. But instead it is 35.5. So these three elements do not follow the rule. Take note. But every other element here follows the rule. So let's apply the rule. What's the rule? Once you have an odd atomic number, once your atomic number is odd, multiply by 2 and add 1. Once your atomic number is odd, multiply by 2 and add 1. So let's go. This lithium has an atomic number of 3. 3 is an odd number. So 3 times 2, 6, 6 plus 1, 7. Boron 5, 5 times 2, 10, 10 plus 1, 11. Fluorine 9 times 2, 10, 10 plus 9 times 2, 18, 18 plus 1, 19. 9 times 2, 18, 18 plus 1. So multiply by 2 and add 1. 11 times 2, 22, 22 plus 1, 23. 13 times 2, 26, 26 plus 1, 27. 15 times 2, 30, 30 plus 1, 31. 19 times 2, 38, 38 plus 1, 39. And class, on the board here is the first 20 elements with their atomic numbers and their atomic masses successfully achieved without any stress. This may carry any book? No. Without any book or any help. This is breaking down chemistry. This is breaking it and then it's finding out for you to understand. This is how you should have been taught chemistry. If you were taught chemistry like this, probably you will not need Jamb class. If you were broken down to you step by step like this. And this is how we teach all your topics. When we get to the tougher topics like organic chemistry, most secondary schools did not cover organic chemistry. They did not finish it. Most Nigerian secondary schools, 80% of Nigerian secondary schools did not finish chemistry syllabus to the end. You just went to write WAEC and thank God you passed one way or the other. But in this class, I'm going to cover the key topics in the syllabus. I'm going to demystify organic chemistry. I'm going to demystify nuclear chemistry, radioactivity. Some of you have issue in there, radioactivity. Balancing of chemical equation. The gas laws, kinetic theory of matter, electrolysis, we're going to break it down. Are we together? The experimental aspect of chemistry. When we talk about upward delivery, what gas is delivered is what is collected via upward delivery. Now we call upward delivery and downward delivery. Are you aware? What gas is collected via upward delivery? Who can give me an example of a gas that is collected via upward delivery? That's one aspect of chemistry that worries students a lot. And also experimental aspects. When they start talking about when two reagents mix and it produces a white precipitate is formed, which of the following is the correct ion that is formed? When you say white precipitate, what does it signify? What turns lime water milky? Which of the following reagent must have been mixed to turn lime water milky? Those aspects of chemistry. When you say asbestos dust, when you talk about what is the component, which of the following is the component of glass? What are the allotropes of carbon? All those components of chemistry that is very tough, that students are struggling with, we're going to break it down so you can pass your Jamb this year. Yes. Who can tell me an example of a gas that's collected via upward delivery? What gas is collected via upward? Isotopy. We're going to break it down. Thank you. Abundance says, sir, you are the best. I'm going to break it down. Someone say, now I understand better, sir, you are the best. Thank you for the compliments. Thank you. Someone say, what do you do for the ones that do not obey the rule? The ones that don't obey the rule, just cram their atomic mass. They are not much. Just cram their atomic mass. They are not much. Those ones that don't obey the rule, just cram their atomic mass. They are not much. Those guys that don't obey the rule, cram their atomic mass. They are not much. Those ones that don't obey the rule, cram their. They are just 3 now. Imagine cramming 20. I've reduced your cramming from 20 to 3. Just 3. It's easier to cram just 3 elements: hydrogen, nitrogen, and chlorine. The rest, you have a rule to obey them, right? Now let's go further. Let us go further. Because the next thing I want to teach you now is a commonly asked question in Jamb. Did you notice something? Did you notice that when we define atomic number, we said the number of protons present in the nucleus of an atom, right? When we define atomic mass, we say number of proton and neutron, right? Notice that we define atomic number and atomic mass, and we never made mention of electron. Why? Atomic number is the number of proton present in the nucleus of the atom of an element. Atomic mass is the number of proton and neutron present in the nucleus of an element. But nobody made mention of electron. But yet, don't forget, that when we started this topic, we said elements are made up of atoms. And atoms are made up of proton, neutron, and electron, right? So every element has proton, neutron, and electron. But yet, when determining the mass of an element, we don't consider electron. Atomic mass of an element, also called mass number, right? Atomic mass of an element, also called mass number, is number of proton and neutron only, despite the fact that electron is also in the element. Electron also makes up every element. Every element has electron, but it's not considered when considering the mass of an element. I'll tell you why. Why is electron not considered? Can someone give me an idea in the comment section? Why is electron not considered when defining the mass? An element made up of proton, neutron, and electron. But when you want to measure the mass, we don't consider electron. Why? Who can tell me a good reason in the comment section? Why is electron not considered when determining the atomic mass of an element? Who can give me a good reason why electron is not considered? Why is electron not considered? Why is electron not? Someone say because it's neutral. No. Why is electron not considered? Class. Electron is not considered. I would have made it tougher for you more, but there's no time. So let me just explain why. Electron is not considered because electrons cannot be trusted. Electrons are not considered because electrons cannot be trusted. Let me tell you something. Among these three particles, proton, neutron, and electron, these two are embedded deep within the nucleus of the atom of the element. Deep within the nucleus, we have proton and neutron. Class, the proton and neutron are embedded deep within the nucleus. Go back to the definition of atomic mass. Go back to the definition of atomic number and atomic mass. Atomic number is the number of proton present in the nucleus of the atom of the element, right? Atomic mass is the number of proton and neutron present in the nucleus of the atom of the element. In the nucleus of the atom, note that keyword, in the nucleus of the... So proton and neutron are found in the nucleus of the atom. Where are electrons found? I'll tell you why they are not considered. Electrons are found at the outer shells, orbiting around the shells. Electrons are found outside. But proton and neutron are found inside. What does that mean? It means that these electrons that are found outside can easily be lost. So we cannot trust them. So they can go today and come tomorrow. Have you ever noticed that in chemistry, we always have gain of electron, loss of electron. But you have never heard of gain of proton or gain of neutron. You cannot gain or lose proton or neutron, except during the radioactive decay. In radioactive decay, the element loses half of its mass, decays to half of its mass, and local half-life. We'll get there later. Too many things, but we'll get there later. Let's calm down with this one first. The point is this: you will never hear of loss of proton or neutron. Only electrons can be lost. Class, I want to ask you a question. If you keep something inside your house, in your cupboard, in your safe, inside your house, and lock it inside your house, you lock it, then you lock your room, then you lock your parlor, then you now lock your house door, and you lock your compound gates. That thing is inside, and you keep another thing outside your compound gates. Which one will you trust that will be lost? Which one will you trust? The one inside is, you trust that one, right? But the one outside can easily be lost, right? Electrons are outside. Because they're outside, they can easily be lost. So we don't consider them in atomic mass of an element. We don't consider electrons in the atomic mass of an element because they can go anytime. Are we clear? So something that can easily be lost or gained cannot be trusted. Cannot be what? Trusted. Now let's go. Class. The next thing we need to look at now. Proton and electron. How to determine the number of proton, neutron, and electron for the first 20 elements. How to determine the number of protons, neutrons, and electrons for the first 20 elements. How to determine the number of protons, neutrons, and electrons for the first 20 elements. How do we determine the number of protons, neutrons, and electrons for the first 20 elements? Now, class, it's very easy. The number of protons is there already. You know why? Because atomic number is number of protons. And atomic number is number written as subscript, right? The atomic number is the subscript. So class, the number of protons for each of these elements is clear on the board. Hydrogen is 1, helium is 2, lithium is 3, oxygen is 8, aluminium is 13, chlorine is 17, potassium is 19, magnesium is 12, sodium is 11. Easy. Very, very easy. Class, also, number of electrons also easy. Let me tell you something. Elements can exist in two states. Elements can exist in two states. Elements can either be charged or uncharged. Elements can exist in two states, either charged or uncharged. When elements are uncharged, it means they are neutral. It means they are what? Neutral. Elements in their uncharged states are neutral. When elements are charged, there are two types of possible charges. Either they are positively charged or negatively charged. When elements are charged, it's either they are positively charged or negatively charged. But elements in their uncharged states can also refer to as what? Neutral states. Class, I want to ask you a question. These elements on the board, are they in their uncharged state or their charged state? Let me know in the comment section. Let me know in the comment section. These elements on the board, are they in their charged state or uncharged state? Let me know in the comment section. Let me know. These elements on the board, are they in their charged states or uncharged state? Let me know. Oh, congratulations. We have crossed 100 minutes of learning. Check the time on the live. Over 100 minutes. This is good. I told you these guys were going to be very serious. Oh, these 116 minutes we have been learning, standing, learning, breaking down chemistry. Let me know in the comment section. These elements on the board, are they charged or uncharged? Those saying send me this video. Have you registered for my class? If you have not registered, you won't get this video. And you can't see this video on my YouTube channel. You cannot see it. It's locked. The only reason why you're on this live is because I sent you the link myself. The only reason why you're on this live now is because I sent you the link myself. If you went to my YouTube channel by yourself, you will never see this video. It is locked. If you went to my channel by yourself tomorrow, if you go to my channel tomorrow morning, you will not see this video on my channel. It is locked. I didn't put it in public view. There are many classes I've taught, but students cannot see them because they are private. They are for my students. Are we together? So if you're still saying send me this video, make sure you have registered with us. At least now, if you are still doubting after now, then you're on your own. You have seen the class live. After this class, message me, sir, how can I join you? Let us find a way. Sir, I don't have money now, but let us find a way. Let me join this class. I need to join this class. Before you go far, thank God I started with you from the beginning. Before you go far, let me join this class, sir. Before you go far than this, thank God I started from the beginning. If you're in this class, you started with us from the scratch, from the beginning. This is the first topic in chemistry. Impure substance, pure substance. After elements, I will touch compound. After compound, I will touch mixture. After mixture, I will touch separation techniques. I will touch separation techniques. Filtration, evaporation, sublimation. I will touch it. Centrifugation, chromatography, paper chromatography, thin layer chromatography, centrifugation, crystallization, fractional crystallization, distillation, fractional distillation. Plus, I've been teaching this thing. Don't worry yourself. This is the Jamb master. This is the Jamb master. This is your Jamb journey ends this year. Just don't worry. Just go and thank God. You're in this class. Your Jamb journey ends this year. Yes, I said, are these elements on the board charged or uncharged? These elements on the board, are they charged or uncharged? Some people are saying charged. Some people are saying uncharged. Some people are saying neutral. Are you aware that neutral and uncharged means the same thing? Neutral and uncharged means the same. If you are uncharged, it means you are neutral. We have more charge. We have more charge than uncharged. If we were to take a vote, then the charge will win. But thank God, chemistry does not depend on votes. It's either wrong or right. Class, I'm sorry to announce to you that those of you that went for charge, you are wrong. Because these elements on the board are clearly uncharged. These elements on the board are clearly uncharged. Class, you cannot be charged and it will not be visible. Class, for an element to be charged, you will know because you will see the charge. You will either see plus on top or minus. And how many charge does it carry? You see it. Let me show you an example of this element. Look at sodium. This sodium Na is uncharged. If sodium were to be charged, you see Na plus. Yes, there's one other aspect that confuses students in chemistry. Why is sodium carrying plus 1? But when it is calcium, it is carrying plus 2. Why is aluminum carrying plus 3? This part of chemistry has eluded some students. It has become a mystery. Some of you don't understand. There's one part of chemistry that even me, teachers, I still ask some questions till today. How many of you remember that in our secondary school in chemistry, our teacher told us that when an element loses electron, it becomes positively charged. I asked my teacher, sir, why is it that someone will lose and become positive? Let's use our common sense. If you lose, shouldn't you be negative? But in chemistry, when you lose electron, you are positive. But when you gain electron, you are negative. That is one aspect that first confuses students in chemistry. And most teachers are not patient enough to explain it very well why it's like that. This night you will know why elements are positive when they lose electron and they are negative when they gain electron. When elements lose electrons, they become positive. When they gain electrons, they become negative. It is counterintuitive in the sense that why is it that when someone loses, you are positive? The normal common sense should tell us that when you lose, you should be negative. If you have 10,000 naira and you lose 2,000 naira, you are not in the negative. You are not going to 8,000, right? You are reduced. Your money has reduced. But in chemistry, when you lose electron, you become positive. When you gain electron, you become negative. In this class, you're going to know why. Why is that so? Everything about ions, you're going to know and I understand well. Follow me. Follow me carefully. Follow me carefully. Follow me carefully. Class, you can clearly see that these elements are charged. This one's here. +1, 2 plus, 3 plus. So class, when someone is charged, it is obvious, it is evident. It cannot hide. So class, it is clear that these elements on the board are uncharged. I will tell you why elements become charged. Don't worry. What is the foundation? What is the history? Why elements started becoming charged? I'll tell you why. Every element started by being uncharged. But I'll tell you why some elements started wanting to become charged. I'll tell you why. I'll give you the reason why elements started trying to become charged. And later, I want to be charged. I want to be charged. I'll tell you why. I'll tell you why. Let's take it step by step. But for now, all elements here are uncharged. And class, uncharged means you are neutral. And neutral means that you have equal number of positive and negative. Let me show you something. Follow me. Please follow. Make sure you are following me. Make sure you are following me. Class, neutral means that you have equal number of positive and negative components. Class, if an element has 4 positive particles and 4 negative particles, it's a popular law in electrostatics that unlike charges attract, while like charges repel. Am I correct? Unlike charges attract, like charges repel. Class, plus and minus are unlike, so they attract and they cancel each other out. So plus will kill minus, plus will kill minus, plus will kill minus, plus will kill minus. And the element becomes neutral or uncharged. So class, when an element is neutral or uncharged, it means that it has equal number of positive particles and negative particles. When an element is neutral or uncharged, it means it has equal number of positive particles and negative particles. Are we following? What's the implication of that? The implication of that is that when you come to each of these elements and you're asked to state the number of proton and electron. Class, what are the positive particles called? Proton, right? What are negative particles called? Electron, right? So it therefore means that for elements in their uncharged states, they have equal number of positive and negative particles. That means they have equal number of proton and electron. Elements in their uncharged or neutral states have equal number of proton and electron. Because proton means positive, electron means negative. The fact that they are uncharged means that all their protons have cancelled out all their electrons, so there is no charge. What makes someone charged? Someone is charged if he has more protons than electrons, or if he has more electrons than protons. Follow me. What determines whether someone will positively charge or negatively charge? Let me show you something. Follow me carefully, please. You'll learn a lot today. Class, in this case, someone had 4 protons and 4 electrons, and every proton cancels out each electron. So there's 0 charge, uncharged, neutral. There's no charge remaining. But let's see a scenario whereby you have 4 protons, plus, but you have only 3 electrons. What happens? Proton cancels electron, protons cancel electron, proton cancels electron, but there's still one more proton here. So this element now gains a positive 1 plus, positive next charge, Na plus 1. This is the foundation of charges in chemistry. So anytime someone is having a plus 1, it means that he has more proton than electron. He has more proton than electron, plus 1. But let's look at another scenario, class. What if it was the plus that was 3 and the minus was 4? So plus, and we have minus. What happens? Sorry. Plus, and minus. We have more minus than plus. Before we had more plus than minus, right? Now we have more minus than plus. What happens? Plus cancels minus, plus cancels minus, plus cancels minus. This person has a negative charge, minus. So this person will now be minus 1, Cl minus 1. I'll still come again with this. This is just a preliminary explanation. I'll come again. What that tells us, I'm not trying to tell you that when someone is positively charged, it's because it has more protons than electrons. And when an element is negatively charged, it means because it has more electrons than protons. Anytime you see someone carrying a positive charge, just know that it has more protons than electrons. And when someone is carrying a negatively charged, it means it has more electrons than protons. Because protons are positive, electrons are negative. But when someone has equal number of proton and electron, all the protons will cancel out all the electrons and there will be no charge. That person will be neutral or uncharged. Neutral or uncharged. And these elements on the board are neutral or uncharged because if they were charged, they will carry their charge. Plus, charges cannot hide. Charges cannot hide. So what this means is that for every element here, they contain equal number of proton and electron because for you to be uncharged or neutral, your number of proton and number of electron must be the same. So class, if you say number of proton for hydrogen is 1, it means the number of electron for hydrogen is also 1. If you say number of proton for carbon is 6, number of electron for carbon is also 6. If you say number of proton for magnesium is 12, number of electron for magnesium is also 12. If you say number of proton for chlorine is 17, number of electron for chlorine is also 17. If you say number of proton for potassium is 19, number of electron for potassium is also 19. So when these elements are uncharged, they contain equal number of proton and electron. If you are following me till now, type "we are with you, sir." I am with you, sir. Type "I am with you, sir." If you are following me till now, type "I am with you, sir." If you are following me till now, type "I am with you, sir." Someone say, "I just they drink water to clear eyes." They drink the water, they go. Say, some of you were saying we are not serious. You are saying class now, you won't run, Abi. Just they drink water, they go. If you are with me, type "I am with you, sir." Type "I am with you, sir." Someone said you are too good, sir. Thank you. Thank you. Thank you. Thank you. If you have any of your friends that you love that is writing Jamb, you better drag them here. If you have any of your cousin, your brother that is writing Jamb, don't pass alone. Don't go and get 300 alone and then you know how you get so you did not tell me. Your friend will not be angry with you. Some of you, after your friends see your score, they will quarrel with you. Some of you will lose your friend after you leave this class. Someone said, "How will I register?" You are saying class now. Good. Message me after this class. Someone said, "How will I register?" Good. After this class, message me on WhatsApp. Let me drop my WhatsApp number. Good. You are saying class now. Good. You can't attend my class and not testify. It's not possible. 081-824-24350. So when we were doing that live session, I was showing you the results of my former students. Some of you were doubting, thought it's not really results. You have not even passed your exam. You already believe in. Imagine you now pass. Won't you send me your result and send me testimonies? So when I'm showing your testimony to next year's set, they will think I'm lying again. So people don't believe, but they cannot even believe that someone can get 300 in Jamb. They don't even believe. Some results I even show the person's face. Some people are still doubting. I show the person's face. I show the red number. Go and check, the red number is there. Some people are still doubting. It's funny. Like even anyway, people even doubted Jesus. So who am I? People doubted Jesus, the Son of God. People doubted him. Who am I? So it's very, very funny. There's one I showed her face, Glitch Princess. She's got 303 Jamb. I showed her face. I showed her red number. No, she said, "Sir, don't clean anything. Post my result. Sir, motivate them. Post my result." Gift Princess got 303 in Jamb. Currently studying nursing. She wanted nursing. Some of you are going for a big course, so you need a very wicked score. You better go and clean your eyes now. Don't sleep. Your colleagues are competing with you. They are not sleeping. You better go and clean your eyes. You better go and drink Nescafe. Don't sleep. Sit up and learn. You must pass. I don't train weak students. I train strong students. You must pass. You want to join my class? Sir, I like the way you teach. Sir, I'm now convinced. I like the way you teach. I want to join your class. Message me on WhatsApp after this class. I'm not online now, but you can just say hi. When I come online, I'll see. Don't just say hi. Go straight to the point. There are many people messaging me. "Sir, I want to join your class." Say, "Sir, I want to join your class. I don't want to miss out this year. I don't want to miss out this year." Message me on WhatsApp. Message me on WhatsApp now. Message me on WhatsApp now. "Sir, I want to join your class. After this class, when I come online, I will see it. When I'm done with class and I come online, I will see it. Let's keep going. This is a marathon class. Sit up, sit up, sit up, sit. You have to sit up, you have to sit up, sit up. In my class, with discipline, you must be a good student. You must pass that Jamb. You must pass that Jamb. You must pass that Jamb. Let's go. So message me on WhatsApp. Message me on WhatsApp. Now, what was I saying? Where did I stop? So I said, all these elements here, the number of protons and electrons are the same. The number of protons and electrons are the same. Why? Because they are on charge. When elements are on charge or neutral, the number of protons and electrons are the same. So if I ask you what is the number of protons or electrons for sulfur, type in the comment section. Let me see if you are following me. What is the number of proton and electron for sulfur? What is the number of proton and electron for sulfur? What is the number of proton and electron for sulfur? What is the number of proton and electron for sulfur? What is the number of proton and electron for sulfur? What is the number of proton and electron for sulfur? You see, they have started giving me another name now. Next year, if I call myself Jamb Crusher, it's my students that what's the number of what? Proton and what? Electron for sulfur. What is the number of proton and electron for sulfur? Please, as Zizat or Lighton said, I'm lost. Just rewind the video. This is a live class. You can rewind and then watch again. You can rewind and watch again. If you are lost, maybe you just joined us, that's why. Rewind and watch again in your own time. What's the number of proton and electron for sulfur? Someone said 32, you are wrong. Go. Number of proton and electron for sulfur is not 32. Class is not 32. That's atomic mass. 32 is atomic mass. Class, all of you are saying 32. You are wrong. It is not 32. Who is hypnotizing you guys with 32? Every spirit of 32 go away now. Every spirit of 32 go away now. Class, 32 is the atomic mass. Atomic number of proton and electron. Proton and electron is 16, 16. God bless you. Good luck. Good luck. God bless you. It's 16, 16. Proton is 16. Electron is 16. Proton is 16. Electron is 16. Because proton and electron are the same. They are equal. Don't forget. Elements have the same number of proton and electron. Elements have the same number of proton and electron. Who is he saying 32? Elijah will really remove that 32. Now remove that 32. It's an error. Number of proton and electron are the same. 16, 16. Class, sulfur, 16, proton, electron is 16, 16. This 32 is atomic mass, so this 32 is atomic mass. This 32 is atomic mass. Number of proton and electron is 16. Number of proton and electron is what? Is 16. Number of proton and electron is what? 16. Class. How then do we now get number of neutrons? Class. So we now have a way of getting number of proton and electron, right? Why? Because once the element is on charge, number of proton and electron are equal to each other, right? So number of proton for carbon is 6, electron is also 6. Number of proton for silicon is 14, electron is also 14. But what of neutron? So we have sorted out proton and electron. What of neutron? How do we get number of neutron? Who can tell me in the comment section? How do we get number of neutron? Tell me in the comment section. My best chemistry student for this year. Tell me, how do I get number of neutron for elements? Tell me in the comment section. My best chemistry student for this year. My best chemistry students for this year. Tell me in the comment section. Tell me in the comment section. How do we get number of neutron? My best chemistry student. How do we get number of neutron? My best chemistry student. How do we get number of neutron? Someone says 16 multiplied by 2. No. How do we get number of neutron? What's the formula to get number of neutron? I'm watching your comments. Someone say by multiplying. How do we get number of neutron? No. Number of neutron is atomic mass minus atomic number. To get number of neutron for an element is atomic mass minus atomic number. Number of neutron. Atomic mass minus atomic number. Number of neutrons, atomic mass minus atomic number. Number of neutrons, atomic mass minus atomic number. Yes, Elizabeth Adebisi, well done. You got it. Mass number minus proton number, which is atomic number. Good. Atomic mass minus atomic number. So now that I've told you, someone should give me what is the number of neutron. Everybody on the give me what is the number of neutron for aluminium. What is the number of neutron for aluminium? Let me know in the comments. What is the number of neutron for aluminium? What is the number of neutron for aluminium? First answer. Let me see the first answer. Let me see the first answer. What is the number of neutron for aluminium? What's the number of neutron for aluminium? Someone said 8. Someone said 14. Ifeanyi Chidera said 14. Perez Gadget said 14. Wisdom Miyakazi said 14. Binta said 14. More answers, more answers, more answers. Those that are done, what's the number of neutron for phosphorus? Let me know. What's the number of neutron for phosphorus? What's the number of neutron for phosphorus? Phosphorus. What's the number of neutron for phosphorus? What is the number of neutron? After doing for aluminium, let me know the one for phosphorus. What is the number of neutron for phosphorus? Phosphorus. What's the number of neutron for phosphorus? Okay, Ajoke said 13. What's the number of neutron for phosphorus? Someone says 16. Edafe Wisdom says 16. What's the number of neutron for phosphorus? I'm reading all comments. I'm reading all comments. Wisdom Yekazi said 31 minus 15. Excellent. Well done. Well done, Wisdom. Phosphorus. Someone says 16. Phosphorus. So let's do the correction, class. For aluminium, it is 27 minus 13. Because number of neutrons is atomic mass minus atomic number. Atomic mass minus atomic number. So aluminium, atomic mass for aluminium is 27. Remember, atomic mass is the one written above. Atomic number is the one written below. So atomic mass minus atomic number. 27 minus 13 will give you 14. That's aluminium. For which is the other person? Phosphorus. 31, atomic mass 31 minus atomic number 15. 31 minus 15. That will give you 16. So number of neutron for aluminium is 14. Number of neutron for phosphorus is 16. Good. Now another classwork. Find the number of proton. Write down. Everybody write down. Write down your book now. Write down in your book now. Write down in your book. Write down in your book. Find the number of proton, neutron, and electron. Find the number of proton, neutron, and electron for chlorine. Find the number of proton, neutron, and electron for chlorine. And find the number of proton, neutron, and electron for chlorine and nitrogen. Find the number of proton, neutron, and electron for chlorine and nitrogen. Classwork. Find the number of proton, neutron, and electron for chlorine and nitrogen. I'll give you 1 minute to solve. Find the number of proton, neutron, and electron for chlorine and nitrogen. Chlorine and nitrogen. Chlorine and nitrogen. Once you solve, once you are done, say done. Chlorine and nitrogen. Proton, listen to the question very well. Proton, neutron, and electron for chlorine, that's Cl, and nitrogen, N. Chlorine and nitrogen. Find number of proton, neutron, and electron for chlorine and nitrogen. When you are answering, let me know the one you are answering for. For chlorine and nitrogen. If you are on our channel now and you have not subscribed to our channel, you are not helping yourself. Hit that subscribe button immediately. If you are on this channel and you have not subscribed to the channel, As you are watching us now, hit the subscribe button now. Like, go and do it now. Because when Jamb is getting close, there's some updates I'll be dropping. If you miss it, you're on your own. There's some updates I'll be dropping. If you miss it, you'll be on your own. As you're on the channel now, you check, are you subscribed to the channel? Are you a member of this channel? Hit the subscribe button now. If you have not subscribed to our channel, hit the subscribe button now. It doesn't take you any time at all to subscribe. Just hit the subscribe button now. Check, have you subscribed to our channel? Hit the subscribe button now. So number of proton, neutron, and electron for phosphorus, for chlorine and nitrogen. Number of proton, neutron, and electron for chlorine and nitrogen. Number of proton, neutron, and electron for what? Chlorine and nitrogen. Marvelous. I'm saying you. What are you doing for carbon? I said chlorine. You are doing carbon. Chlorine. Who is saying CC6 for chlorine? Chlorine. Some of you are taking carbon as chlorine. Chlorine is ClO. No, carbon is C. Chlorine is Cl. Carbon is C. Chlorine is Cl, carbon is C. I'm watching all your answers. I'm seeing those that are not doing the classwork. I am seeing those that are not doing the classwork. Number of proton, neutron, and electron for chlorine and nitrogen. Class, let's do correction. Class, for chlorine. Chlorine is 35.5 atomic mass and 17 atomic number. Number of proton, neutron, and electron. Class, this 17 represents number of proton, atomic number 17. Also, electron is also 17 because they are the same. Remember that elements have the same number of proton and electron when they are on charge. Please note the word when they are on charge. When they become charged, it's not the same. When they become charged, it is not the same. But for now, these people are all on charge. I'll also start giving you questions when they become charged. So make sure you are still around. Class. Neutron is, how do you get number of neutron? Number of neutron is atomic mass minus atomic number. Number of neutron is atomic mass minus atomic number. What's atomic mass? 35.5. Minus atomic number. What's atomic number? 17.5. So neutron is 18.5. So class, number of proton for chlorine is 17. Neutron is 18.5. Electron is 17. Who got this? If you got this, say I got it. 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 If you got the Elizabeth Adebisi, yes, well done. If you got this, say I got it. If you got this, say I got it. If you got this, say I got it. If I Chidera said I tried, yes, good. There's no harm in trying. Well done. At least you tried. Well done. I like the energy. I like the energy. Some people have joined us back. We're now 80. We're now 80. We're now 71. We're now the number is dropping, increasing and dropping, increasing and dropping. Well done. Those of you that have been here. If you have been here since the beginning of this line, you have not left once. Say Say, I have not left. Let me see. Let me see those that have been. You've been watching since the beginning. You have not left once. Say, I have not left. Say, I have not left. You started with us from the beginning and you have not left once. You have not left. Let me know those. Say, I have not left. You started with us from the beginning and you say, and you have not left once. You have not left since the beginning. Since the beginning, you have not left. For nitrogen, 14 and 7. Proton, neutron, and electron. Class, this 7 here represents atomic number, which is number of proton, 7. Electron and proton must be the same, 7, 7. Now, neutron is 14 minus 7. Because number of neutrons is atomic mass minus atomic number. The number of neutrons is atomic mass minus atomic number. Atomic mass is 14, atomic number is 7. So 14 minus 7 giving you 7. So this is 7, 7, 7. If you got this, let me know in the comment section. I'm about going to the charged one. I'm about to change you how to get the one for charged. If you got it, let me know in the comment section. If you got it, let me know in the comment section. So people have never left since we started. You have not left once. I have not left. I have not left. Elizabeth said, I have not left, but I did not start from the beginning. Well done. I'm knowing my student from this class. This is where I will know my student. Don't worry. My real student that I will use as testimonial for next year. I'm seeing evidence already. My real student I will use for testimonial next year. If you have subscribed to our channel, say I have subscribed. If you have hit the subscribe button on our channel, say I have subscribed. If you have hit the subscribe button on the channel, say I have subscribed. I have subscribed. If you have hit the subscribe button on the channel, say I have subscribed. Class, we are going to the top one now. We are going to the top topic now. I have subscribed. If you have hit the subscribe button, I have subscribed. I have subscribed. Class, let's go to the top one now. Class, this one we just did is very simple. This one we just did is very simple. This one we just did is very simple. Let's go to the top one. Class, elements can exist in two states, charged and uncharged, right? Elements exist in two states, charged and uncharged. So every element here is uncharged. What causes elements to become charged? What causes elements to become charged? I'll show you something now. Follow me. Class, there are some special elements here that every element wants to be like. What are those elements? Those elements are called the noble gases. The noble gases. Are you aware? Are you aware that every element wants to be like the noble gases? Are you aware? Every element wants to be like noble gases. What's so special about the noble gases? We're going to find out. We're going to find out because we're going to be looking at what we call electronic configuration. Remember when I told you that protons and neutrons are embedded deep within the nucleus of the atom, right? But electrons are found out at the outermost shells outside. Class, there are 4 types of shells that store electrons. We have the K shell, you have the L shell, you have the M shell, and you have the M shell. If you remember this from your secondary school, say I remember. You remember this from your secondary school, say I remember, I remember, I remember. You remember this from your secondary school, say I remember. Remember this from your secondary school, say I remember, I remember. KLMN shell. These are the 4 shells that help us to store electrons. K shell, L shell, M shell, and N shell. K shell, L shell, M shell, and N shell are the 4 shells that help to store electrons. Class, the K shell, each shell has the number of electrons they can store. That's the maximum, the optimal amount of electrons they can store, the maximum amount of electrons they can take. Each of these shells have the maximum amount of electrons they can take. For the K shell can take maximum of 2 electrons. The L shell can take maximum of 8 electrons. The M shell can take maximum of 8 electrons. The N shell can take 18 electrons and above. The K shell can only take 2. The L shell can take 8. The M shell can take 8. The N shell can take 18 and even more electrons. Follow me carefully. Follow me carefully. Follow me carefully. Follow me carefully. The K shell can take 2. The L shell can take 8. The M shell can take 8. The N shell can take 18 and above. Can take more than 18 electrons. Follow me. So class, follow me. So any element that can give K shell just 2 electrons, K shell will be so happy. Now let us look at how many electrons does hydrogen have. Because number of electrons that an element has determine how many shells it will need. Class, hydrogen has only 1 electron. You don't expect hydrogen to employ the services of L shell or M shell or N shell. It doesn't need them. It only needs K shell. Now there's something I must tell you too in chemistry. There's what we call the half-Bowles rule. In chemistry, we call the half-Bowles rule. According to the half-Bowles rule, it tells us that electrons should be filled first in orbitals of lower energy before orbitals of higher energy. Class, as you are going from K shell to L shell to M shell, the number of energy level is increasing. Class, amongst these 4 shells, the person that has the lowest energy level is the K shell. The lowest energy level, lowest energy level. And as you're going from K shell to L shell to M shell to N shell, the energy level is increasing. N shell has the highest energy level. Class, when filling electrons in shells, we fill first in shells of lower energy before shells of higher energy. So class, hydrogen has 1 electron. It will not go and start entering N shell first. It will start with K shell. When K shell is filled up, it moves to L shell. When L shell is filled up, it moves to M shell. When M shell is filled up, it moves to N shell. So we'll start with K shell first. But class, hydrogen has just 1 electron, so it needs only K shell. So if you ever ask for the electronic configuration for hydrogen, it's 1. What is electronic configuration? Electronic configuration is the arrangement of electrons in the shells of the atoms of an element. How electrons are arranged. Electronic configuration shows how electrons are arranged in the shell of the atoms of an element. How electrons are arranged. Electronic means electron. How electrons are arranged or configured. Configuration, configured. How electrons are arranged in the shell of the atom of an element is electronic configuration. So electronic configuration for hydrogen is 1 because it has only 1 electron. Helium is 2. Helium is 2 and helium is very special. Do you know why? Helium is one of the first noble gases. I told you every element wants to be like noble gas. Don't forget that statement. I'm coming back there. All these elements here wants to be like noble gas. What's special about the noble gas? The noble gases have the exact amount of electrons that their shells need. Class, for K shell to be absolutely happy, it needs 2 electrons. And helium provides that exact 2 electrons. So K shell is very happy with helium. And every other element wants to be like the element that they're happy with, right? The favorite child. Helium. Now, so the electronic configuration for helium is 2. So hydrogen is 1, helium is 2. Let's keep going. Who is the next element? Lithium is 3. Lithium has 3 electrons. But don't forget, you must start filling from K shell first. So K shell will take 2 out of the 3. Lithium will say, now I have 3 electrons now, which remaining 1. It will now go to L shell and drop the 1 electron. So the configuration for lithium is 2, 1. The electronic configuration for lithium is 2, 1. Make sure you are still with me. You are the one that have been saying you want to learn, right? Many of you, when we are ready to group, you say, sir, when are we starting? Now we have started, you are running. You know, Jamb students, they just have ginger, temporary ginger. When the team becomes serious, they run away. You just want ginger. People are not actually serious. When we created a group and ready to say, when are we starting now? So when are we starting now? Now class is going now. You have seen the heat now, you are running. So I'm sure the people have gone, I'm sure. But the ones say, when is starting now? So, it's a scam, it's a this. So class has started now, you are going running. So stay serious. You want to pass, right? You're going for nursing, you're going for medicine. Open your eyes. As a medicine student, you read for 18 hours sometimes. I deal with medicine students in university here. I deal with nursing students. They don't sleep or you jack, you read. You must jack, you must read. The course I studied, human anatomy. We read books, big books, anatomical books, Kerusias, Gray's Anatomy, Last Anatomy. Are we together? We read books, so you don't sleep. You sit up, you sit up, you sit up. You say you want to learn, right? You say, sir, when are we going to be serious? So when are we starting now? We are starting now, you are running. So sit up. You want to sleep now, right? So you're the one disturbing us before now, you want to sleep. So sit up. Charge your phone, sit up. Let's go. So we said lithium, 3 electrons. 2 in the K shell, 1 in the L shell. 2 in the K shell, 1 in the L shell. Now, who is the next one? Beryllium. But class, watch. Lithium is not as balanced as helium. Helium just has 2 electrons and K shell needs 2 electrons. Perfect. Are you aware that this lithium that has 3 electrons, this 1 electron given to L shell, L shell is not happy. Out of 8 electrons that L shell needs, it's just giving him 1. It's not happy. Something will happen later. I'll show you. Now for beryllium, beryllium has 4 electrons. So beryllium will be 2 in the K shell. Remember, start filling from the K shell first. 2, then 2 in the L shell. That's 2, 2. For boron, has 5 electrons. That will be 2, 3. Remember that L can take up to 8. Boron is 2, 3. 2 plus 3, 5. Carbon is 2, 4. 2 in the K shell, 4 in the L shell. Nitrogen is 2, 5. 2 in the K shell, 5 in the L shell. Oxygen is 2, 6. 8. 2 plus 6, 8. Fluorine is 2, 7. You can see that this L shell is still carrying because until it gets to 8. Neon is 2, 8. Another person that is very happy, another noble gas. Neon. Class, as soon as neon comes around, these 2 shells are happy. Because K shell needs 2, it gives him 2. L shell needs 8, it gives him 8. Who is still following me? Say, sir, I am following you. Sir, we are with you till the end. Type in the comment section. Sir, this jam, I'm not writing jam next year. This is my last jam. I go stay, I go open my eyes. Type in the comment section if you are with me. Let me know those that have gone. Let me even see the number that's still remaining. Let me know those that have gone. 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 Someone said, I thought M shell carries 18 electrons. Which school did you go to? Which school did you go to? Which school did you go to? Please erase that. Oh, thank God you are here. If you are with me, say, sir, we are following you. No leave, no transfer. No leave, no transfer. Sir, we there, we gallant. Sir, we gallant. We gallant. Sir, we gallant. Sir, we gallant. Sir, we there here. We there here. We there with you. Everywhere good. Someone say, men, they go work tomorrow. Okay, we have working class students here. Sit up. People are not the ginger, not the ginger. So when are you starting now? So I'll be serious now. We don't serious now. Someone say, I'm going to school tomorrow. Sit up, sit up. Someone say, oh, I never chop. Sit up. Someone say, my power bank, they cry. 3 hours gone, exactly. You people have seen class now. I told you, when I teach, you will run. Good. You have seen class now, right? Good. Make sure you subscribe to our channel. When we start when Jamb is getting close, we're going to have a Jamb camp. I told you about the Jamb camp, right? I told you about the Jamb camp. Yes, no leave, no transfer. We gallant. Yes. We're going to have a Jamb camp. That Jamb camp, get ready. You delete your TikTok first. 1 month to Jamb, my students don't open TikTok. All those dancing in TikTok, you will delete your TikTok first. You must pass your Jamb. 1 month to Jamb, all my students delete their TikTok. No TikTok. Operation No TikTok. TikTok is the #1 enemy of Nigerian students. Operation No TikTok. Operation No TikTok. 1 month to your exam, no TikTok. Facebook, delete it. Jamb camp. I will confirm the ability that I have my Jamb camp. We're going to Jack. We're going to hold Jamb and Jack. After this year, you know you are not writing Jamb again. You are not writing Jamb again. And you're not getting less than 300. So you see, helium, neon, these guys are special. Why? They have the exact number of electrons for each shell. After neon now, let's go after neon class, sodium. Class, sodium is 11. So 2 in the K shell, 8 in the L shell, 1 in the M shell. Magnesium is 12. 2 in the K shell, 8 in the L shell, 2 in the M shell. Aluminum is 13. 2 in the K shell, 8 in the L shell, 3 in the M. Silicon is 14. 2 in the K shell, 8 in the L shell, 4 in the M shell. Phosphorus is 15. 2 in the K shell, 8 in the L shell, 5 in the M shell. Sulfur is 16. 2 in the K shell, 8 in the L shell, 6 in the M shell. Chlorine is 17. 2 in the K shell, 8 in the L shell, 7 in the M shell. Argon is 18. 2 in the K shell, 8 in the L shell, 8 in the M shell. Argon, another special element. Argon, another special element. Why is it special? The exact number of electrons that each of the shells need. M needs 8, it has 8. The exact number of electrons that each of the shells need, it gives it to it. Are we together? Very, very stable. Now, class, let's keep going. Potassium is 19. Remember, we are only doing the first 20 elements. Potassium now, 19, means that 1 in the N shell. So potassium is 2881, 19. And calcium is 20, 2882. Now, class, we have just done the first 20 elements. Don't worry, for those going to work and those that are going to school, we have some students that are still in secondary school that are in our class. I will soon stop. I will end with an assignment. Let me finish this aspect, then I'll stop. This is just to warm you up. Get ready. The last time I did 100 minutes class, people were tired. Now I've increased it now. The next one I'm going 5 hours. If you dull, you lose. I don't work with dull students. But you must not spoil our record. You must pass your jam. You must pass your... So go and charge your phone. Charge your phone. Get ready. Get ready. Some of you were thinking I joke with my... I don't joke with my classes. Please. It's an insult to me that you even think that. The fact that you think that this person is not serious with the class, it's an insult. I teach jam how many years now? I don't joke with my classes. Now you go tire yourself. You'll be the one that will be tired. But because of people that are going to work tomorrow morning, tomorrow is Monday, Monday is a serious day. Some of our students are still in secondary school, but their parents enrolled them in our class to go and learn. I will soon stop, but I will end with an assignment. I will end with an assignment. Are we together? So stay to the end, at least know that I will soon stop. So stay to the end, but please sit up, sit up. As we are going to be increasing the hours, you must learn. You must learn. You must learn. Now, class, you notice that these 3 elements, they have the required number of electrons that their shell needs. Do you know what will happen? All these other elements, they are not jealous of these 3 elements. So what happens? They will now start giving out their electron or going to look for a way to collect electron to be like these elements. In the process of giving out electron, they start acquiring charges. They want to be like this guy, but they can never be like these guys. Because these guys are themselves without even acquiring any charge. But these other elements, let me show you an example. Who is this currently? This is calcium, 2882. 2 plus 8 is 10. 10 plus 8 is 18. 18 plus 2 is what? 20. Calcium, 20. But calcium wants to be like argon. Who is argon? Argon is 2, 8, 8, 18. Argon is 18, right? Argon has exactly the number of electrons in each shell. 8, 8. What do you think calcium will do? Calcium is 20, 2882. Calcium is 1 here. Calcium is 2882. What must calcium do to be like argon? Drop your, in the comment section, drop your suggestion. What must calcium do to be like argon? What must calcium do to be like argon? Drop in the comment section. What must calcium do to be like argon? 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 Yes, Operation No TikTok. I like this set. Everybody's typing Operation No TikTok. Excellent. Someone say network really unmoved me today. Oh, don't worry. They are recorded. They are recorded. We are recorded. Every live session is recorded. If you have registered with our class, we are going to get everything. You are going to get everything. Please, if you joined the class late, rewind the video to the beginning and watch from the beginning after this class so that you can get everything very well. What must calcium do to be like argon? What must calcium do to be like argon? What must calcium do to be like argon? Someone said to give out electrons. It will lose 2 electrons. Good. Give out 2 electrons. What must calcium do to be like argon? Yes, you are correct. It must give out 2 electrons. Someone said calcium will borrow from nitrogen. No. What must calcium do to be like argon? Class, for calcium to be like argon, before I say that, let me tell you one more thing. I saw a comment that says, sir, you are too fast. Are you aware that YouTube allows you to reduce the speed of your experience when you're watching this class? Do you know there's a place you go to, click on settings in your YouTube now. Go to playback speed. I want to help slow learners. You're a slow learner. Go to playback speed in your YouTube. Go to settings, go to playback speed. Now reduce the playback speed. It will slow me down, it will slow down the way I'm teaching it. If you're a slow learner, are we together? But if you're understanding as I'm teaching it, don't slow it because it will be too boring for you. But you feel that I'm too fast, you can correct it with the last advantage of an online class. In a physical class, you cannot slow down your teacher. But an online class, it's in your phone there. Say, I wish I'm your phone, I will help you. Go to playback speed, slow down the pace. It will slow, I will be talking small. But it will be boring for you. So that you sit up. Our advice you do, instead of doing that, challenge yourself to understand faster. Let me tell you, when you push yourself to understand faster, you become a better student. If you slow it down, it means you are slowing down your own intelligence too. If you slow down your speed now, it means you are underrating yourself. You don't want to improve because you're going to challenge yourself. Say, I understand this one. Push yourself to understand this one instead of slowing it down. Are we going backward or forward? Are we together? So don't go back. If you are slowing it down, you understand it, but you're not going back. You're reducing your intelligence. Why not challenge your brain to understand? Those people that understand, they don't have to it. Push yourself, say, I must get this thing and watch it again. Instead of doing playback, rewind and watch again. Instead of doing that playback, why not rewind the video and watch again? When you're in an online class like this, stop saying, sir, you're too fast, or you don't understand. It's a waste of time. Why not just rewind the video and watch what you missed again? You can rewind your life experience. It will show you again everything you have missed. You can rewind it. So stop saying you are too fast. Stop saying, sir, I don't understand. Rewind. Some of you are still too used to physical class. Physical class is still in your system. So you have forgotten that this is online. You can rewind and watch again. You can rewind like this and watch again. Stop saying you are too fast. You are showing that it shows that person is a village person. You are not in tune with technology. Something is in your phone there, you can rewind, you say you are too fast, or sir, come again. Just rewind the video. You have your phone, you have the power. The power is in your hand. Online class gives you the power. That's the power of online class that physical class cannot give you. Online class gives you the power to come again 10 times. You can rewind it 10 times and watch till you get it. So stop saying come again. Stop exposing yourself that you don't know what's up. Oh. Just rewind your video and watch again. Stop saying come again. Stop saying you are too fast. Nobody can be too fast in online class. Rewind and watch again. I don't want to see that. Don't go and embarrass yourself somewhere else and say you are too fast. At least get a little bit of just rewind the video, watch them again now. Please don't go and fall your hand in another place. So let me help you now. Stop saying you are too fast. Stop saying sir, come again. No. Just rewind the video. You're wasting time by saying come again. Just rewind the video. And don't think you are going to go ahead of you. Wherever we go, you can forward it back and watch us again. Do you get? Anything we do when you're rewinding it, you can see it's still saving, you still watch it in the front. So calm down. Understand this technology. Some of you have not really understood the power of this online. That's why you're narrating it. If you have not registered for our class, go and try and register. Online class gives you power to watch again and again and again. Like if you register for this class, after this class is over, ask me for the link. Sir, please just send me the link. Let me sit down later in the morning and rewatch. I'll send to you. Are we together? Yes. If you're watching this class and you have not registered, because I allowed you. If you go to my YouTube tomorrow, you will not see this video on my YouTube. It's not there because it's locked. But it's the only person I sent the video to that can see it. And that will be a registered member. So please, you see a class that can help you like this. Very soon we'll open our Jamb camp. If you miss all these kind of things, you will miss out. Though. Join us. Message us on WhatsApp. This is my WhatsApp number. Sir, can I join you? I want to join your class. Some people you are seeing in this class, they paid for the class. Register so that you will get the other things. It's not good that you stop here and you don't get the next things you will learn. Register with us. Let it cost you something so that you know that this is the price I paid for my 300 in Jamb. This is the price I paid for my success in Jamb. You will not write Jamb next year. Now let me continue. So I've cleared that now. Class. Calcium has to lose 2 electrons to become like argon. Calcium has to lose 2 electrons to become like argon, 18. But calcium has 20 now, right? It wants to be like argon, 18. Why does it not want to be like potassium? Because potassium and calcium still have the same problem. The person that is perfect is argon. Why? Because argon is 288. All the shells have the number of electrons they need. So calcium wants to be like argon. It will then lose 2 electrons, class. But when you lose electrons in chemistry, what did I just say before, class? Tell me in the comment section, when you lose, what happens? Tell me in the comment section. When you lose electrons, what happens in chemistry? 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 When you lose electrons, you become positive. When you lose electrons, you become positively charged. When you lose electrons, you become positively charged. When you lose electrons, you become positively charged. Take note. In chemistry, when you lose electron, you become positively charged. Now, how many charge will you carry? What is the number of charge you will carry? The number of electrons you lost. Class. Calcium will lose 2 electrons to become argon, right? So calcium will now become Ca2 plus. This is the thing I was telling you about chemistry, that in chemistry, it is funny because how can you say I become positive when I lose? The normal brain, normal common sense, if you lose, you should not be positive, you should be negative, right? Normally common sense, using your common sense, if you lose, you should be negative, not positive. But in chemistry says when you lose, you are positive. Why is calcium 2 plus? Because it lost 2 electrons. Calcium is 2 plus because it lost 2 electrons. Notice that everything I'm teaching, I'm saying it like 3 times. Calcium is 2 plus because it lost 2 electrons. So someone will not come and say you are too fast. Then there's a problem somewhere. Calcium is what? 2 plus because it lost 2 electrons. Now, it now becomes Ca2 plus. Now, class, I want to remind you of something. This calcium now and this calcium, are they still the same thing? Yes or no? Let me know in the comment section. This calcium and this calcium, are they still the same thing? Let me know in the comment section. And if your answer is no, what's the difference between them? Let me know in the comment section. The 2 calcium, are they the same thing? The 2 calcium, are they the same thing, and why? The 2 calcium, are they the same thing? The 2 calciums, are they still the same? No, right? Good. The 2 calcium are no longer the same. Why? Remember when I started this topic, I said elements can either be charged or uncharged. Remember I said it? The elements can either be charged or what? Uncharged. Class, another name for uncharged is neutral. I said that, right? Another name for uncharged is neutral. Class, this element here is uncharged or neutral. This one here is uncharged or is not carrying any charge, so it's uncharged. Another name for uncharged is neutral. See how many times I'm saying that same thing again and again to make you understand. Uncharged or neutral. Look at this one, it's charged. You can see clearly the charge 2 plus. Why is it carrying 2 plus? Because you have to lose 2 electrons. Why do you have to lose 2 electrons? It wants to be like argon. All elements want to be like noble gases. But by trying to be like noble gases, they either lose or gain electrons. So Ca2 plus. Now class, I want to tell you one more thing. Who remembers when we're doing proton, neutron, and electron for elements? Who remembers when we're doing proton, neutron, and electron for elements? Remember? What will be the number of proton, neutron, and electron for this calcium and for this calcium? Someone should tell me. Let me know in the comment section. What is the number of proton, neutron, and electron for this uncharged calcium and for this charged calcium? Is it the same thing, yes or no? Let me know in the comment section. What's the number of proton, neutron, and electron for the uncharged calcium and the charged calcium? What is the number of proton, neutron, and electron for the uncharged calcium and the charged calcium? What is the number of proton, neutron, and electron for the charged calcium and the uncharged calcium? What's the number of proton, neutron, and electron? Thank you, Blessing Chidima Omosa. You're really a genius. Thank you, thank you, thank you. Why I did this class for everybody, so you can see that seeing is believing. Some of you were doubting us. You can see life. This is a live class. Some of you were doubting us before. Class, I asked you a question. What's the number of proton, neutron, and electron for the 2 calciums? Are they the same or are they different? I'm waiting for your answer. I'm waiting for your answer so we can round up for today. Tell me, what is the number of proton, neutron, and electron for the normal calcium and the charged calcium? Okay, Emmanuel Miracle said the charge calcium, proton is 20, neutron is 20, electron is 20. The charged one, what of the uncharged one? I'm waiting for your reply. I'm waiting. This is an interactive class. Elizabeth at ABC, the uncharged, 20, 20, 20, charged. 18, 22, 22. Interesting. Good luck, Abunike. To tell you that I'm reading all comments. I know my students from the comment section. On charge, calcium, proton 20, electron 20, neutron 20. Who else is talking? Abundant, charge, proton 20, neutron 20, electron. Nobody has gotten it yet. Nobody has gotten it fully yet. Emmanuel Miracle, on charge, 20, 20, 20. Okay, you got the on charge. Emmanuel Miracle, you got the on charge. Emmanuel Miracle, charged, 18, 22, 18. Interesting. We'll find out. Let us do the correction. Let us do the correction. Let us do the correction. Class, when calcium is uncharged, this is 40, this is 20. Proton, neutron, electron. Follow carefully. Class, this number here under, is it not the atomic number? Yes, atomic number is one written under. And atomic number means number of proton, right? Number of proton is 20. But when element is uncharged, it means the number of proton and electron are the same. So electron is also 20. Remember we said that, right? But neutron is 40 minus 20, right? Atomic mass minus atomic number. Number of neutrons is atomic mass minus atomic number. I'm repeating again for those who are saying we are too fast. Number of neutron, atomic mass minus atomic number. 40 minus 20 is 20. So when calcium is uncharged, the number of proton, neutron, and electron is 20, 20, 20. When calcium is uncharged, the number of proton, neutron, and electron is 20, 20, 20. When calcium is uncharged, the number of proton, neutron, and electron is 20, 20, 20. But when calcium becomes charged, class, the atomic mass does not change, it's still 40. Remember, the atomic mass is number of proton and neutron embedded deep within a nucleus. Whether it is charged or uncharged, nothing touches the proton and neutron because they are inside. Remember, proton and neutron are inside. Nothing touches them. It's electron that changes. Electron is outside. Remember, I told you that when we started the class. If you joined late, go back and rewind after this class. If you joined late, there's a part of this class you will not understand until you rewind and watch well. Calm down and watch it well later. If you have lost now, it means that you did not start the class with us, so you just rewind from the beginning. But the good thing is that this is our first major chemistry class in the Jamb Master class. We have been waiting so nobody will miss out. And this is why I posted this link to everybody, to give you one final chance to join our class. Because now this is still the beginning. So as you're joining now, you're not missing anything. You started with us, you started with. After now, you will not see my link again. It means that you don't want to join. We've given you all proofs, but you don't still want to join. No problem. I will now focus on my registered students. No problem. But if you have watched this video, it means that you have started with us. You are very lucky. Very, very lucky. It means you have not missed anything. We started with the beginning of chemistry. Matter. Matter is anything that has weight and occupies space. If you join late, rewind, you see that's what we started. Matter. We started with matter, the simplest thing in chemistry. So you have no excuse to fail gen chemistry. Maybe I pick it from the foundation and I bring it up to the end. So you are covered. I will do the same thing for physics, mathematics, biology. You know you must pass your Jamb. English, the same thing. Now, for charged calcium, the atomic mass is 40. The atomic number is 20. Class, number of proton does not change whether you are charged or uncharged. Proton doesn't change, it's still 20. Neutron will never change, it's still 20. Take note. Number of proton and neutron does not change whether it is charged or uncharged. Number of proton and neutron does not change whether it is charged or uncharged. Number of proton and neutron does not change. Who changes is the electron, class. Electron is the one that has been lost, class. Don't forget that calcium had to lose 2 electrons to become like argon. So you're going to minus 2 electrons from the normal electrons it has. 20 minus 2, 18. So it is 20, 20, 18 is the number of proton, neutron, and electron for calcium 2+. Are you aware that some students still miss this in the exam? They still fail this kind of question in the exam. Some students will still pick 20, 20, 20 when they ask me for Ca2+. Some students don't understand how to subtract 2 electrons from here to make it 18. And that's what I'm teaching now. So calcium 2+ is 20, 20, 18. Who got this? 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 Princess Tammy, well done. I see you. Say, sir, I'm active. You didn't mention my name. Princess Tammy, well done. Princess Tammy, well done, well done, well done. Who got this? Who got this? Someone say, now I know, sir. This is good. You are learning. Now I know. Now I know. If I said I understand now. Good. Well done. Well done. Well done. Class. So looking at someone like potassium. Potassium is 19, which is 2881. Potassium is 19. The electronic configuration of potassium is 2881. Class, don't forget, every element wants to be like the noble gases closest to it. Every element wants to be like the noble gases closest to it. Class, you don't expect potassium to want to be like helium. Helium is too far for potassium. So the people that calcium and potassium would like to emulate is argon. Even all this chlorine, sulfur, phosphorus, they want to be like argon because they are still close to argon. Are we together? The people that want to be like neon, the next noble gas neon, is all this sodium, magnesium, aluminium, silicon. All these people want to be like neon, and all this fluorine, oxygen, nitrogen, carbon wants to be like neon. Who wants to be like helium, hydrogen, lithium, beryllium, boron? All these people are around helium, wants to be like helium. So note that every element wants to be like the noble gas closest to it. In order to do that, they have to either lose electron or gain electron. So class, potassium is 19. Which is 2881. Now, everybody understands how we got 2881, right? If you don't understand, rewind. It's an online class. Rewind and watch again. I've said it several times. Class, there's nothing like I don't understand in an online class. It's a taboo. It's impossible not to understand an online class. Why? Because if you do this, they just rewind and watch again. So you see how powerful online class is. You don't have this power in physical class. 2881. Potassium 19. Class. Potassium wants to be like argon. Argon is 288, perfect. He has to let go of this one electron. When it was calcium that was here, calcium has to let go of 2 electrons, right? But potassium has to let go of just 1. So when you lose the electron in chemistry, you become positive. And how many charge will you carry? It's the number of electrons you lost. You lost 1. So potassium becomes K plus 1. Potassium becomes K plus 1. Don't forget, calcium became Ca plus 2 because it lost 2 electrons. But potassium lost only 1, so K plus 1. So if someone asks you to write the number of proton, neutron, and electron for normal potassium and charged potassium, it's not going to be the same thing, right? It is not going to be the same thing. Class, give me, before I give you assignment and we round up. Before I give you assignment and we round up, you have tried. If you stay to the end of this class, if you are still here, say, sir, I'm still here. If you stay to the end of this class, well done. You stay to this time, say, I am still here. I am still here. I am still here. Class, you will give me the number of proton, neutron, and electron for uncharged potassium and charged potassium. Don't forget 39, 19, 39, 19. Give me number of proton, neutron, and electron for uncharged potassium and charged potassium. Give me number of proton, neutron, and electron for uncharged potassium and charged potassium. Give me number of proton, neutron, and electron for uncharged potassium. Good. Pinky Bella, I'm still here. Emerson, I'm still here. Joy Maxwell, I'm still here. Elijah, I'm still here. Good. Oh, these are my students. Good luck, Abunike, I'm still here. Elizabeth Adebisi, I'm still here. I love this. Binta, I'm still here. Basit Olayinka, I'm still here. Ifeanyi, I'm still here. Faith, I'm still here. Wisdom, I'm still here. Emmanuel Miracle Perez, I'm still here. Afolabi, interesting. Good. Princess said, I don't understand this topic when they teach it in school, but you are the best, sir. Thank you. Thank you. Those that are praising us, thank you. Thank you. Thank you. We appreciate. Answer the question I just gave you. Agwata, I'm still here. Good. Edafe, Wisdom, I'm here. Oh. Mary Simon, I'm still here. Excellent. 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 Grace Adesewa, I'm still here. These are my best students. I'm already seeing my best student for this year. Number of proton, neutron, and electron for uncharged potassium and charged potassium. Ajoke Vibes, I'm still here. Well done. Messi Chinemerem, well done. If you have not joined our class, message me immediately after this class ends. Sir, how can I join you? I cannot miss this class. I've already started with you now. Let me just continue. I like the way you teach. Abundance, I'm here. Oh, good. Well done. Those dropping the answer. I'm saying you. Elizabeth Adebisi, well done. Perez, well done. Perez Gadgets, well done. So give me the answer for uncharged and charged. Uncharged and charged. Blessing Chidima says, I dare your back. Victor Okoro said, I'm still here. Good. I love this set. I love this set. Faith Akane, P is 19, N is 20. But let me know whether it's on charge you're answering or charged. Let me know if it's on charged or charged you're answering. Let me know. Let me know. Princess Temi, sir, I'm still here. Well done. Well done, everybody. Well done. Class, for uncharged potassium, the number of proton, neutron, and electron for uncharged potassium. Proton is 19, because this is 19. Electron is also 19, because proton and electron are the same when they are uncharged. Neutron is atomic mass minus atomic number, which is 39 minus 19, 20. 39 minus 19, 20. This is uncharged potassium. Uncharged potassium. Now let's go to charged potassium. For this charged potassium class, don't forget, in charged potassium, whether you are charged or uncharged, these two guys never change. So just put 19 and 20 here. These two guys are inside the nucleus. They will never change. They are safe. They don't increase, they don't reduce. Class, a very simple arc. These two guys don't change. It's this guy that is the problem. Class, 19. But plus 1 means he has lost 1. In chemistry, when you have lost, you have lost. When you have minus, you have gained. Don't forget. Plus 1 means he has lost 1 electron. So minus 1 from 19 becomes what? 18. 19, 20, 18. 19, 20, 18. If you got this, let me see your hand. If you got this, let me see your hand. You got it, let me see your hand. If you got this, let me see your hand. You got it, let me see your hand. We are rounding up. We are rounding up. Let me see your hand. Excellent. Congratulations, everybody. You stay. This is 3 hours, 187 minutes. It's a milestone. 187 minutes. Should we do 200 minutes before we go? Should we do 13 more minutes? Let us change ourselves. 13 more minutes, guys. Do we do that? Let me know. Let me know. Sir, let us get to 200 minutes. Sir, let us get to 200 minutes. Sir, let us get to 200 minutes and we'll go and rest for the night. Sir, let us get to 200 minutes and we'll go and rest for the night. Sir, let us hit our milestone. There's something to do to your confidence. So I did 200 minutes of class. Sir, I did 200 minutes of class. It will help your confidence to read well. Good. Let me know. Sir, let us fire down. Say fire on, sir. 200. Let's do 200 minutes. This is 188 minutes of live class. 188 minutes of live class. 188 minutes. Excellent. We still and we are teaching for 188. We are doing 200 minutes before we go today. Challenge accepted. Our next challenge will be 300 minutes. Our next class, 300 minutes. This is 188 minutes. We are going to 200 minutes and we'll close so that everybody go and sleep. We are going to 200 minutes. This Jamb, they will hear what this year. Let's go. Class. Let's go now. So far, I've been showing you positively charged ions. Let me give examples of negatively charged ions. Let's look at someone like chlorine. Chlorine is 17. Class, follow this. Chlorine also wants to be like argon. Now, argon is 288. Argon is 288. But chlorine is 17, which is 287. While others are giving out electron, chlorine needs to gain 1 electron to be like argon. Chlorine needs to gain 1 electron to be like argon. So chlorine, we gain 1 electron, class. And in chemistry, when you gain, you are minus. So that's minus 1. In chemistry, when you gain, you are minus. In chemistry, when you gain, you are minus. And the number of charge you carry is the number of electrons you gained. Chlorine gains 1 electron to be like argon, so minus 1. Look at sulfur. Sulfur is 16. Sulfur is 286. 286. He also wants to be like argon. Sulfur has to gain 2 electrons to be like argon because 8 minus 16 needs 2 more. So when sulfur gains 2 electrons, it becomes S2 minus. So why chlorine becomes Cl minus 1 or 1 minus? Anyone is correct. 1 minus or minus 1 is correct. Or 2 minus or minus 2 is still correct, class. Sulfur is S2 minus because sulfur has to gain 2 electrons. In chemistry, when you gain, you are minus. Please, for those that also have too fast. When you gain electron, you are minus. The number of electrons you gain will determine the charge you carry. So when you see chlorine minus 1, it means it gained 1 electron. When you see sulfur minus 2, it means it gained 2. Look at phosphorus 15. Phosphorus also wants to be like argon. Currently, phosphorus is 285. 285. Phosphorus needs to gain 3 electrons to be like argon. Phosphorus gaining 3 electrons now becomes P3 minus. Because phosphorus gains 3 electrons. Class work is to give me the number of proton, neutron, and electron for these 3 ions in their uncharged states and their charged states. Give me the number of proton, neutron, and electron for these 3 ions in their charged states and uncharged states. I believe before you are done with that, we'll eat 200 minutes. We are going to eat 200 minutes in the Jamb Masterclass. Our first 200 minutes in this year 2026 Jamb. Our first 200 minutes in this year 2026 Jamb. Let me see your answer in the comment section. Give me the number of proton, neutron, and electron for chlorine in uncharged state and charged states. Sulfur in uncharged state and charged state. Phosphorus in uncharged state and charged state. Let me see your answer. Number of proton, neutron, and electron in their uncharged state and their charged state. Number of proton, neutron, and electron for these 3 elements in their uncharged state and their charged states. Let us go, guys. Let us go, let's go, bros. Let's go, guys. Let us go. Gospel, I say, thank God I'm here. Good. If you are in my Jamb Master class, you don't know what God has done for you, guys. You don't know what God has done for you in this year Jamb. You don't know. If you have not registered with us, message me immediately I end this live. I want to see your message immediately. If you are really serious, if you're actually a serious student, you will message me immediately. Say, how can I do it? I want to join you. How much? Let me pay. I don't mind. I want to pass my Jamb. We must get to 200 minutes. I've given you a classwork. Solve. I'm waiting for your classwork. Yes. Elizabeth Adebisi has started already. She said chlorine charge 17, 18.5, 18. On charge 17, 18.5, 17. Balikis Olabisi, I like this set. I love this set. I like this set. CL 17, 18, 17. The other one 17, 18, 18. Whether you got it or you missed it, it's good. You attempted it. At least you attempted it. Well done, class. I like this set. This is good. Make sure you are solving. Let me see your answers. Anyone you have done, send first. Don't wait till you solve everything. Send the one you have done. Let us see. Guys, 7 more minutes to 200 minutes. 7 more minutes to 200 minutes. We are close, guys. We are close to 200 minutes in the Jamb Masterclass. 200 minutes of demystifying chemistry. 200 minutes of saying bye-bye to chemistry. After this year, no more Jamb chemistry again. 200 minutes. Guys, we are close. 7 more minutes to 200 minutes. We are going to do it. We are going to do it. We will do it. Let me see your answers in the comment section. Guys, let me see your answer. Let me drop your answer in the comment section. Let me see your answer. Don't leave. Join us to enter 200 minutes. Don't leave. 6 minutes to go. Don't miss your blessing. 9 minutes. 6 minutes to 200 minutes. Don't leave. Let us end together. Just 6 minutes. Achieve your first 200 minutes class. Some of you have never been in a class learning for 200 minutes before. How many minutes did they spend in secondary school? 30 minutes for one session. Solve. Let's see. Solve. I'm seeing your comments. Well done. Good luck. Faith, Akane, well done. Abundant. Everybody's typing. Everybody's dropping their answer. Well done. I like this set. Everybody's dropping something. Make sure we join us to 200 minutes. So do not leave. Join us to 200 minutes. Well done, class. Everybody's dropping their answer. Let me be doing the correction. Class, for chlorine, normal chlorine, we have 35.5 and we have 17. Number of proton, neutron, and electron. Proton is 17. Electron must also be 17 because they are the same. Remember, when they are uncharged, proton and electron are equal. Neutron is 35.5 minus 17. Atomic mass minus atomic number. 35.5 minus 17 is 18.5. Chlorine. This is uncharged chlorine. Uncharged chlorine. Let's now go to charged chlorine. Class, Cl minus 1, charged. This is 17 and this is 35.5. Don't forget, proton and neutron will never change. So let's replicate this down. 17 and 18.5. They will never change. Don't forget. This is the guy that will change. Class, what happened to chlorine that it became minus 1? They didn't lose or gain electron. It gained 1 electron, right? When you gain, you are minus. Remember, when you gain electron, you are minus. When you lose electron, you are plus. Don't forget. It gained 1 electron. So from 17, it will move to 18. So this is the correct answer for charged chlorine. Who got this? Who got this? Who got this? Who got this? Now let us go to sulfur. Let us go to sulfur. Sulfur, proton, neutron, and electron. Sulfur is 32 and 16. Proton is 16. Neutron is 32 minus 16. 16. Electron is also 16. So proton and electron is 16, 16. Let's now go to charged sulfur. Charged sulfur, proton, and neutron don't change. Remember, 16, 16. But what happened to the electron of sulfur? Class, 2 minus means that sulfur has gained 2 electrons. So 16 plus 2, 18 electrons. Sulfur has 2 minus. And the last one, phosphorus. The last one, phosphorus. Class, phosphorus is 31, 15. Number of proton, neutron, electron. Proton is 15, as you can see, because this is 15. Electron was 15 because they must be the same when they are uncharged. But neutron is 31 minus 15. 31 minus 15 is 16. 31 minus 15 is what? 16. 31 minus 15 is 16. Now let's go to charged phosphorus, P3 minus. We have 31 again and we have 15 here. Proton, neutron, electron. Class, proton is 15, this I will not change. Neutron is 16. What must be the electron? Class, what happened? 3 minus means he has gained 3 electrons. So from 15 plus 3 becomes 18. If you got the 3, say I got the 3, sir. If you got the 3, say I got the 3, sir. If you got the 3, class, count down to 200 minutes. Count down to 200 minutes. If you got the 3, people have left. They have left just at the 9 minutes when they are supposed to join the 200 minutes. Count down to 200 minutes. The Jamb Master Online class, our first 200 minutes of the year 2026. We have milestones in our Jamb Master class. We have done 100 minutes. This is 200 minutes. Our first learning for 200 minutes. Our next target will be 300 minutes marathon learning. 300 minutes marathon learning. This is going to 200. We are counting down now. We are counting down. This is so good. 200 minutes of pure chemistry, Jamb chemistry. 200 minutes. If you got the 3, say, sir, I got the 3. If you got 2 out of 3, say, sir, I got 2 out of 3. If you got 1, say, sir, I got 1. If you got the 3, let me know. Then I'll give you assignment and we'll round up. While you are typing, let me be writing the assignment. Let me be writing the assignment. Find the number of proton, neutron, and electron. Find the number of proton, neutron, and electron for the following. In their charged and uncharged states. In their charged, fluorine. Charged and uncharged state. Fluorine. In their charged and uncharged state. Number of proton, neutron, and electron for boron. Charged and uncharged states. Charged and uncharged state. Fluorine, boron. Fluorine, boron. Magnesium. Charged and uncharged state. Fluorine, boron, magnesium. Fluorine, boron, magnesium. Fluorine, boron, magnesium. Yes, give me these 3 elements. Assignment. Assignment. Give me these 3 elements in their charged and uncharged states. Class, I've just introduced the foundation of chemistry Jamb. I've just given you the foundation. I've just built your foundation of chemistry Jamb. In our next class, so this is elements for you. Don't forget it's elements, compound, and mixture. In my next class, I will now introduce compound. I will now introduce mixture. You understand why? Class, if you notice chlorine gain 1 electron, did he gain it from the air? No. He gained it from another element, class. That element is gaining it from, they have to now bond. So that's chemical bonding. This is the reason why elements bond. You have electrovalent bond. You have what? Covalent bond. You have coordinate covalent bond. You understand, also known as dative bond. You have hydrogen bonding. You have the metallic bonding. You have the Van der Waals bonding. These are things that in my head I've not opened any book so far. Chemistry is here, guys, and I'm going to transfer it. Knowledge transfer. I'm going to transfer the knowledge to you, guys. Congratulations, I'm sure. Currently, we have done 200 minutes. I'm 100% sure. Clap for yourself. Clap for yourself. If you are still live now, drop a fire emoji. Drop a fire emoji on the comment section. You made it to 200 minutes. Drop a fire emoji in the comment section now. You are a special student. You're a unique student. You stayed from the beginning, minute 1 till 200 minutes of pure learning. That even God is watching. Say, this girl wants to pass her jam. I must give her nursing. This girl wants to get medicine and surgery. This girl wants to get pharmacy this year. This boy wants to get engineering, computer science. This boy wants to get biochemistry. Wants to get that course he applied for. Drop a fire emoji if you made it. 200 minutes. Congratulations. Congratulations. The Jamb Masters online class. 200 minutes achieved. Goal achieved. Goal achieved. 200 minutes. Our next target is 300 minutes. Our next target is 300 minutes. But this 200 minutes of pure learning. Pure learning. Excellent. Well done, well done, well done. If you're there, you're watching us, you still want to join us, you're watching this video from anywhere, you want to join us, message the number, the WhatsApp number now, and join your colleagues. They are learning for 200 minutes. Jamb is a competition. You must pass your Jamb this year. 081-824-243-50. Message this number on WhatsApp now. If you've watched this class and have not enrolled with us, message me, sir, I want to join. Because the next one, you will miss the milestone. You would have missed this live and not send you the link. You would have missed out of this live and not send you the link. You won't even know that we're having class. You go to my YouTube channel, you will not see anything happening there. But class is ongoing. If I don't send you the link, you will never know that we're having class. And this is how you're missing your police. Sunday, you have slept off. Meanwhile, they have covered all these things. Thank God I allowed you to join today. Message us, sir, I've not joined your class. I know about. I think I want to join now. Message us on WhatsApp. Congratulations, everybody. Congratulations, everybody. Congratulations. 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 Thank you, Samuel. Samuel says, sir, you deserve an award. Thank you. Thank you. Thank you, everybody. You made it. See fire now. Almost. See fire emoji. Everybody, you made it. Med lab. You're going to get your med lab this year. Yes. Pharmacy. You get your pharmacy this year. Yes. Excellent. I like this set. Everybody's we're just united. Everybody's just united. I like this set. I wish we can all be in a physical class so I can even know all of you. This is good. This is good. I like this set so much. I like this set so much. I like this set so much. We are all getting high scores in Jamb. Yeah, Joy Maxwell, physiology, you will get it. You will get whatever course you are applying for, you will get it. All right. Have you taken out the assignments? All right. Thank you very much. Thank you very much for tonight. Thank you for being my guest and staying and indulging me. The Jamb Master will not fail you. The Jamb Master will not fail you. This year will be your last Jamb. This year will be your last Jamb. You made it to 200 minutes. Congratulations. A round of applause. I'm clapping for you. It's not easy. You use your data for something meaningful. TikTok will be wondering, where are you now? TikTok will be wondering, where is this girl? This girl has never stayed 3 hours without coming on TikTok. You left TikTok for 3 hours. You want to pass your Jamb. You are putting your money where your mouth is. Excellent. Guys, tomorrow we have in English. Unfortunately, if you have not registered with us, you will not be able to attend the English class and you will miss that. Ask them for English teacher, how she teaches. They will break down English to your understanding. Tomorrow is English, 8 p.m. So tomorrow is English. Tuesday we have physics. I'm coming back on Tuesday. I'm going to teach physics. We have an English teacher that will teach English, but I teach physics. I'll teach physics on Tuesday. I'm going to stand here on my board and demystify physics. If your problem is physics, don't miss physics class. But you might not get the class if you are not registered with us. Message me now on WhatsApp. Sir, I want to join you. Enough is enough. Even if I'll be paying back, let me start. Let me join. Let me join. See you all tomorrow. Good night. Go and sleep. Have a good night rest. See you tomorrow. You want to join our class? You should be the one messaging me immediately. Have a good night. See you. Do your assignment. In the next class, I'll ask for the assignment first before we start. Thank you. Good night, everybody. Good night, everybody. Good night, everybody. Take care. Take care. Take care. Good night. Take care. Good night. Take care. Good night. Submit the assignment. Those of our private class students, submit the assignment to our chemistry group. I'll open the chemistry group before the next chemistry class. Don't forget mock exam. Mock exam is on Friday. Don't forget. Mock exam is on Friday. 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 You have any friend that wants to write Jamb, you can help them. Let them join this class. You have a friend, you have seen what this class is doing for you. Call your friend, come and join this. This class will help us. Call your friend, call your sister. Hi, they are writing Jamb. This man, come and join this class. I know something good that will help you and I'll hide it. Come and join this class. All right, good night, everybody. Good night. Take care, take care, take care. Tomorrow is English. See you tomorrow. Bye.